You don't need calculator to do this one. No. Press 4 to the power. Press 4 to the power of 5 for me. Press 4 to the power of 5. 4 to the power of 5, this one. That's 1024. Any number to the power of 0 is gone away. Plus, this is 5 factorial into 1 factorial, 5 minus 1 factorial. 4 to the power of 4, press for me. 256. Then 2x plus 5 factorial, 2 factorial, 5 minus 2 factorial. What's 4 to the power of 3? 64. Then you open this bracket. Abi? We'll open this bracket. Are we opening this bracket? Eh? You open that bracket, Abi? But what do you have? 2 to the power of 2x squared. Abi? Okay, that is 4x squared one time. Yes, sir. Is that correct? Eh? Yes, sir. Now, what do we do next? The next one is 5 combination 3. Abi? That is 5 factorial into what? 3 factorial. 5 minus 3 factorial. 4 to the power of this word. 4 squared is what? 16. Open this bracket. 2 to the power of 3. X to the power of 3. That is 8. Is that true? Yes, sir. So we are doing what? We are... Not the frequency. Now, what's the next one? 5 factorial, 4 factorial, 5 minus 4 factorial. 4, this is 4, B? Yes, sir. This is what? 2 to the power of 4 is what? 16. 16x4. Plus 5 factorial into 5 factorial, 5 minus 5 factorial. Any number to the power of 0 is what? 1. That one is gone. 2 to the power of 5. X5. Abi? Yes, sir. So, 0 factorial is 1. 5 minus 0. 5. So this one, I can get is gone, Abi? Yes. We have 10, 24. 5 minus 1. You can just say 5 times 4 factorial, so you can stop with this 4 factorial, you can cancel out. Yes, we have 5. Now multiply this, 256 times 2. We have 512. 512 x. 510. Plus 5 minus 2 is 3, Abi? 5 minus is what? 3. So this place will now be what? 5 times 4 times 3 factorial, because I want to stop 3 factorial down. Split this one, 2 times 1 times 3 factorial. 64 times 4. Eh? 64 times 4. 256. Plus, there's 3 factorial here. So I can say 5 times 4 times 3 factorial, I stop. So this one will cancel out. Eh? Yes. Now this place what? 5 minus 2 is what? 16 times 8. What's 16 times 8? 128. 128 x3 plus, there's 4 factorial here. 5 times 4 factorial over 4 factorial. 4 times 16. 64 x4. This cancel out this because 5, 32 x5. To finalize this math now, you have 10, 24 plus this cancel this. So 5 times 5, 1, 2. 2560 x plus this cancel this 2. 5 times 2 is 10. 10 times 256. 2560 x squared plus this cancel this, have you? This cancel this 2. 5 times 2, 10. 10 times 128. 1280 x cubed plus this cancel this 5 times 64. 320, have you? 320 x4 plus 32 x5. Are you following me?
Yes, sir.
So copy that. Okay. So not much in it. Everybody has 2 minutes to ease yourself. But now, listen. Are you hearing me? But don't cross this place. If you cross this place, you'll be embarrassed. There's toilet here. For the ladies you enter, for the guys you enter. Please do that fast. As you get prepared, they are going to go. All right. We have to see the beauty of the binomial theorem. That is the value of what we were calculating has given us this. And if you observe critically, you see this, in this place you see x is to the power of 0. There are some things you look and check your work and confirm whether your work is correct. If you observe very well, you see that there is no x here. This is x to the power of 1, x to the power of 2, x to the power of 3, x to the power of 4. Have you observed? That's the arrangement. And in most cases, you see how it is. So let's try to see how we can do more examples. If you're asked to find the binomial expansion of x minus 1 over x to the power of 4. How do we do that? X So the value we have say find the binomial expansion find the binomial expansion of this. I think this will be example 3, right? Is it example 3?
Yes, sir.
Find the binomial expansion of 4 plus 2x to the power of 5. No, we have done that one. Of 1 minus 1 over x. Let's use x. X minus 1 over x to the power of 4. If you're asked to expand this, how do we expand this? Find the binomial expansion they are specified. Binomial expansion. So, I believe if you are given this, you can do that. You can solve that if you are given. So in this expansion we have, this is a example 3. Right? That is example 3.
Yes, sir.
So, we now say solution. Mathematics solution. You now bring x minus 1 over x to the power of 4. If you observe critically, you can see that this is the same thing as saying 1 plus minus 1 over x to the power of 4. Is it the same thing as this?
Yes, sir.
So I shift the negative to this so that when I'm using the negative, we'll follow that one. Huh? So remember the law. We start with 4 combination. Have you? Eh? X plus. One time, plus times minus is minus now. Eh? You mean this place? Where? Supposed to be 1 plus. To put it here. No, this is the question now. X is standing on its own. This is a different thing from here. Okay, yes, you are right. So that is x into 1 minus x. So now let's see how we can expand this. How do we start with? 4 combination 0. You know this is, whether you write like this or you write 4 combination 0, it's the same thing. Are you aware of that?
Yes, sir.
So that is 4 combination 0. Then what do we do next? X to the power of 4 minus 1 over x to the power of 0. Is that true?
Yes.
Plus what? Is that true?
Yes, sir.
Plus 4 combination 2 minus 1 over x. This is 4, 3. X squared minus 1 over x squared. Plus what?
Combination 3.
3, have you?
Yes, sir.
I think the one we want to write will be the last 4 combination 4.
Yes, sir.
Is that true? So from that point, what will happen? We know 4 factorial now. Huh? You don't do like that in combination. No, but so long as you understand what we are doing. So long as you understand what we are doing, there's no problem. Huh? I know you like shortcuts well. Yes. So 4 combinations, we all know the 4 combinations 0 should be 1.
Yes, sir.
4 combination 1 is 4. Eh? So this one is already gone. X to the power of 4, any number to the power of 0 is gone. Plus 4 x squared minus 1 x. Abi? This one is what? 4 combination 2 is what? 6. X squared. This square cover up and down. Big boy. Eh? 4 combination 3. You like shortcut. See as you are smiling. This one minus 1 will be that big. 4 combination 4 is 1. So this is. I'm not used to the Bible. This 1, I mean, 1 over x4. Is that true? We check impartial timekeeper. 40 minutes. So this is 4x. This is 4x to the power of 4. You write x to the power of 4, B? Yes, sir. I don't even see, get one happiness will come as I see 40 for that place. What happiness, just feel like God said happiness. We are moving. Yes, minus. This 1x will cancel 1x. Abi? See my friend. You now. 40. So this. What x will remain, Abi? So because of this minus will come out, what do you have? Minus 4x. Is that true? Yes, sir. The minus here will come out. So we have finished that one. Do you have another one there? Now, plus, can this one cancel this one? Abi? Yes, so that place will be 6. Is that true? Yes, sir. What else? This minus will come out. 1 will cancel 1x, remaining x squared, Abi? That will be 4 over what? X squared. Is that true? Yes, sir. You have another one? Plus 1 over. That is the answer. Yeah. That's the answer to the maths. Let's do what? Okay, straight line. Is this one a curve? You don't clear something when it's not an equality sign. You don't clear mathematics that if this equals to something. Are you getting me? Yes, sir. If you have a case like this, you want to make it, you find a common factor. But you don't say multiplying all through when it's not an equality sign. If you do that, that is a Socratic mathematics. Are you getting me? Yes, sir. So, I think it's time for question. Is it up to 1 hour for question? Huh? Okay. Please, any question? Very well. As we are progressing, we disgrace that. Very, very well. It can be negative, it can be fraction, anything. It's a what's a word, anything can happen. Eh? We have a special case of that. We are going to solve it. Today is for binomial. It's one thing at a time. The last day we are going to enter the almighty calculus. When I enter that one, the whole world will hear that. That's when the tension will be high. Anyone that will stay till that time will enjoy calculus. I enjoy this program. Eh? Enjoy it. It's beautiful. All right, this is x to the power of 4 minus 4x plus 6x. Let's go to the next question. Last one. You have any question? We are still on question session. It's time for question, interaction, communication. 2 minutes left. Eh? Stand up. Well, let me ask you a question. The person that invented Pascal triangle, what's the name? I've mentioned a name here. Pascal triangle. I said, what is the name of the person? What's the name? Even though she's hearing, she might even remember to tell me. Yeah? I will John Ororo. John Pascal says what? Okay. So I hope you can know that Pascal triangle. Eh? Can you do the Pascal triangle? Okay, sit down. At least you've learned John Pascal, did you? Mr. White. Hope you can do Pascal triangle. What's the difference between permutation and combination? Permutation is arrangement. Combination is selection. Huh? I hope you've learned now. Permutation is arrangement. Combination is what? Selection. So combine that with the formula so that you can keep the ball rolling. God bless you immediately. Amen. All right. Now let's go back to the major stories. We want to see how, if we have a special case that you are asked to find a specified term. You see, this one we are expanding, and while we are expanding, we don't specify a term. So now, what if you have a case that is a find the 5th term, find the 6th term, find the 7th term? That's a specified term. So that's what you want to check now. Now we talk about the R1 term. the r plus 1th term. You see, the general form of binomial expansion, the general form of binomial expansion or the general term, let me use term, of binomial expansion, a plus x to the power of n is nr a n minus r xr. If this place was x and this place is y, it would be written like n r into x n minus r y r. Are you getting me? So if this alphabet is x, this is x, a is a. So we are using this general formula. If you observe critically, you see that every term we are using dance around this place. Because it's only one this place. What is here is here. What is here is here. If you observe, if you check your book, you see what I'm talking about. Whenever this place is 5, whatever that is in this place is always in the power of y. And whatever you have here is a subtraction of this and this. So if you want to find a specified term, you're using this general formula. So to find a specified term, therefore means that to find the R1 term, the R plus 1 term, that is any number of term, is equals to x n combination r x n minus r y r, where r plus 1 equals to the nth term. That's the formula we are using. If this place is x and r, if you are using x and r, if it is a, this place is a, it's the same thing, whatever the alphabet. So, whatever term we are looking for, we find the corresponding value of that. So, if you sit like this, you will not focus on the class. I know you are not sleeping, but your eye is in this side. So let your eye be in the board. I know you are not using your eye here to hear alone. Be the dose of hearing the word and looking also. Stand up small. Let me show you the angle I'm talking about. Stand up. Stand up first. Stand here. Look at the board first for that. Stand there for 2 minutes. How can you just be sitting down, opening your eye? Is it because, should I clean this one? Is it this one is confusing you? Should I clean this one? Should I teach LCM? So, stand there for 5 minutes. So, if you have any specified term that they're asking to find, this is the formula you are using. For example, if they say find the fourth term of this expansion, the fourth term now, you now say, because they will not give you R, what you now do is I say R plus 1 equals to fourth term. From there, you now make R subject formula. You now put it there and proceed. So let's see how we can use it. Let's use the first example of the question we were using. Open that question we did the other time. The first expansion we did. Open the first expansion we did. Whether Pascal or binomial, I need one expansion. I need one. The first one you expand was x plus y to the power of what? 8. We expanded something like this. If you count that term, look at that your notes. If you count that term, you can remember wrong. If you count that term, you have the first term, second term, third term, fourth term. So count, check how many terms do you have there. Start from the first one. That first one. Let him count that term. Count that term. How many terms do you have in that first equation? Count that your term. How many? That's term. This one you did. How many terms? I get it from. Five terms. How can you have 8? Then you are just starting from 1, 2, 3, 4 like that. How many terms did you have there when we finished? 9. Now I want us to solve the 6th term. Circle your 6th term. What is the value of that 6th term? Is that the 6th term? 56. 56 what? What is that accepted? Is that the 6th term? When you come from the first, second, third. Okay, you did not write. Or you don't even understand what I'm talking about. Get up here. So, what is the answer? He did not do it. Now let's solve it and see. Now, find the 6th term of the binomial expansion. X plus y to the power of 8. That's how they will ask the question. But now sit down so that you solve this thing for me. Find the 6th term of the binomial expansion. So the 6th term will now be, don't forget the formula is n combination r, xn minus r, y r, where r plus 1 equals to the nth term. Abi? That's what I said.
Yes, sir.
Where r plus 1 is what the nth term. So, what is my n here? The n term is 6. Abi?
Yes.
So I will now say r plus 1 equals to 6. That means that my r equals to what? 6 minus 1. R equals to 5. Do you see how I get my r? Now when I get my r, and I will return back to the expression. The formula is n combination r X n minus I y r. What is my n? What is my n? So now say 8 combination. What is, I've gotten my r from this. Abi? Then x to the power of what? N minus r. What is n? What was n? Minus what is r? Then y to the power of r. What is r? Eh? So what is 8 combination 5? 56. So that would be 56. X 8 minus 5. Eh? Then y to the power of 5. Do you have that answer? Eh? The same answer that you wrote now. So I want you to find the 8th term of that something for me. Find the 8th term. The 8th. Find the 8th term for me. Huh? Find the 8th term for me. Didn't put them. So have you been able to do that one? The 8th term, you've not done it. So I've shown you the formula on what to do. Eh? You just find the 8th term. This one, I'm finding the 6th. The same thing, just find the 8th. First of all, you put 8 here and get R. Eh?
8x, y8.
That's what?
8x.
Check your notes now whether it's correct. You don't have this expansion. You don't have this expansion to confirm whether this thing is the. Yeah? Check another person's note that have it now. And this brother. You have to do enough here now. You have to do enough here now. You have to have enough. Okay, let's now see. Is that what I've gotten that? Confirm with that one, is it the same? So you see that when they give you a specified term, when they give you a specified term, you can still solve it and get what we want. So, if they don't give you, if they give you, say find the specified term. Sometimes they can even say find the term independent of x.
Yes.
Hope you know how to do that one.
Yes, sir.
Eh? They say find the term independent of x. Huh?
8x. y7. y7.
Okay. So when you do that, you understand what it entails. You see that this math we are talking about, the Math-A-Thon theorem, is simple. Not so? It's simple now. It's very simple, just for you to understand the rules. When you understand the rules, you get it right. So let's see how we can. Have you gotten the answer? Let's see how we can proceed to another question. Still on the nth term of binomial theorem, we want to, if your question is to find a specified term, the question was to find a specified term. How do you do to get a specified term? Still we have, they say find the coefficients, find, this will be example 4. Eh? Example 4 or 5? So example 5. They say find the coefficients of x to the power 6. This time around they talk about the coefficients. Yes. The coefficient of x to the power of 6 in the expansion, and they now give you the specified expansion. When you give you the specified expansion, you don't have any option than to solve, because when you solve, the answer will surely come out. I told you the other time that mathematics is always speak the truth every time, because when you solve, the answer will come out, cannot hide. True or false? True. Find the coefficients of x to the power of 6 II, the term independent of x, the term independence of x in the expansion 1 over x squared minus x to the power of 18. Now they say find the coefficient of x to the power of 6. Find the coefficients of x to the power of 6 in the expansion. What do we do? Did you do it? Huh? The coefficient of x to the power of 6. Sit well. Stand up and sit well. Hello. Hey. How are that friend? Sit well. Hello? That's my friend. Hello? Stand up. Are you hearing me? Stand up. Now find the coefficient of x to the power of 3, x to the power of 6. If you observe this one, they don't give you a specified term for you to find r. Have you seen? They don't give you a specified term for you to find r. So, but what you need to do there is that you bring the formula out, which is n combination r x n minus r y r. We don't have the number of terms specified. They say find the coefficient. So what you do is that you know that this is for x, this is for y, this is for n. So x equals to 1 over x squared, y equals to what? Minus x, and n equals to what? 18. So we now bring into the formula here. N is what? 18 combination r, we don't know r. Then x, 1 over x squared into n, 18 minus r, we don't know. Now y, what is y? Minus x to the power of r, we don't know r. But what we know is that we are looking for the coefficient of x to the power of 6. So you have to equate it to what? X to the power of 6. Have you seen that? So we don't use any constant for now. Our target is x, because our x is what we are looking for, x to the power of 6. So we are not using this, rather we target this and this. Even this, we don't look the negative sign. Are you getting me? We only focus on x, leave any coefficient. So from that point we have, this is x to the power of minus 2. Notice x to the power of minus 2 times x to the power of r. We don't use this minus and all these coefficients. We only take what belongs to x. There's a negative sign here. It's a coefficient. We are not interested. This one is a coefficient. We are not interested. Our interest is x. Because they say find the coefficient of x to the power of 6. So we have to equate it to x to the power of 6. Equals to x to the power of 6. From there, you can see that from the law of units, the base are the same. So since the base are the same, we now take one base and add the power. That will be minus 2 plus r equals to x to the power of 6. Now, when the base are the same in indices, what do? Take one base. Yes, just take the powers, So since the base are the same, it therefore means that my minus 2 plus r equals to x equals to 6. So from there we can get r. Is that true? R will now be equals to what? 6 plus 2. So therefore my r equals to what? 8. We have gotten r. Yes. Let's apply that method too. You see, if you bring this out, you have x to the power of minus 2 into 18 minus r. Have you seen that? Then x to the power of r. Have you seen that? You don't need this. So x to the power of minus, you multiply this out. 2 times 18 is what? Minus 36. Then this one become plus 2r, right? Then xr equals to x to the power of 6. The same base, minus 36 plus 2r plus r equals to 6. If you must add this, is 3r, right? So therefore, minus 86 plus 3r equals to 6, right? Is that right? So 3r equals to what? 6 plus 86. 3r equals 6 plus 86 what? Eh? 40. Eh? 36 plus 6. So R will now be 42 over 3. Yeah? 14. If I was using the other one, when I want to substitute, I will not use 18 minus R. I will use the other one, substitute there and get the value of what I'm looking for. But if I'm using this one, when I want to substitute, I put it directly to here. I still have the same answer. Are you getting me? So, from that point, we have R to be 14. Now you come back to this equation. Eh? If I was using that one that I was wanting to use, I would have, when I wanted to find the original, I will not fix it. I will use this one and this one to replace that value. But we still have the same answer. When I finish, I will see that one so that you see. So from there we have x. N is what? Taking this one to the original expression, we have n 18 combination 14. X is what? X is 1 over x squared into what? 18 minus 14. Then minus what? X 14. Now what is 18 combination 14? Combination 14. How does minus come in? Eh? 3060. Now, this is 1 over x squared to the power of 4, I mean, then minus 36. Now, if you open this, you have what? This is x 14. The minus will not be there again because it's an even number. So from there, if you multiply this out, what do you have? Huh? Let me take it up. So this is 1 over 30, 60 into what? 1 over x to the power of 8. Have you? Yes. Now, times x to the power of what? X to the power of 14. Can this cancel this? Yes. X to the power of 6, have you? This is x to the power of 6. So it's 30, 60, x to the power of 6. The question was the coefficient of x to the power of 6. Eh? Is this x to the power of 6? So the coefficients. The coefficients. How do you spell coefficient? I'm a shy type. Is 30, 60. So copy that. These are beautiful mathematics for professionals. Like the professional referee. You see, mathematics, I always say that the only thing that can talk to you in life is mathematics. Because it doesn't lie. Look at it. X to the power still comes out. There's no manipulation. When you do it, it comes out. If everybody talks through like math, it will be no problem. Including our politicians. They say this is the answer. The answer, you see the answer even before solving. So please, tell your friends to share this gospel of mathematics to the world. So when I finish, I will use the other method and solve so that you see. So, you know, this thing was 2. The coefficient of x and I, the term independent of x. Are you getting me? That's 2 in 1 question. The coefficient, brain box. The greatest mathematician of our time. You know what me have here now? I'm talking about that, but don't get it. I die go your own way, get you have a name. Nah. So please, just copy. Let us do the B part. This term independent of x means when you finish solving, there will be no x in it. There will be no x. What do we do there to get that? I always give people a picture of what you need to do so that you can even do it yourself. Do you know what to do there? You have the term independent of x. This place equated to x to the power of 0. And the game is over. Mathematics is fun. Nice. I don't know. I don't know. And I'm raised a little up. So you see very well that in each of the topic we do to the fullest, so that you can understand and you can withstand any question that comes your way to any court of law. Just like what I said, Paul, how are you? You cannot come and say for 1 week you don't learn maths. You cannot come and say for 1 week you don't learn maths. When you go out here as a Math-A-Thon member, everybody must fear you in maths. Even the officials are learning maths. Everybody here. If people cooking, they calculate the number of times people want to eat. So, Please, we want to solve the term independent of x. I hope you are through with this. Huh? The term independent of x. So for the term independent of x, so the term independent of x, what you now do there is that you look at what is happening here. Have you seen this? That place that was x to the power of 6, I say x to the power of 0. Are you with me? Because that will be only term that will be independent of x. So from there, this place will now be what? X to the power of minus 2 into 18 minus r, then x to the power of r equals to x to the power of 0, not x to the power of 6 again. Are you there? So this will now be x to the power of what? Minus 36 plus 2r plus r, have you? Equals to x to the power of 0. Have you? So from there, the same base, have you? So what happened? Minus 36. Minus 36 plus 3r equals to what? 0. Abi? Is that correct? So, minus 3r equals to what? 3r equals to minus 30. 3r equals to 36, Abi? So r equals to 36 over 3. Is that right? Eh? What do you say? This becomes 12. So we get r equals to 12. What do? You now come back to this guy here and have 18 combination 12, have you? Into 1 over x squared. 18 minus 12, have you? Then minus x 12. Have you? Are you following me? What's 18 combination 12? Press 18 combination 12. Eh? 18564. 18564 into 1 over x squared. What is 18 minus 12? 6. Then this minus, you know that this minus is part of this. So this 12 will clear off the minus. Eh? Because times 10 in the 12 place, that minus will no longer be there. So no minus again here. That is just right there. Into x to the power of what? 12. This 6 covers numerator and denominator. Have you? So 1 to the power of 6 is 1. That will be 18564 into 1 over x to the power of 12. Then times x to the power of what? 12. This cancel out this. Have you seen x again? So this is 18564. That's the term independent of x. Independent observer. I mean, that is independent of x. Eh? Eh? My friend. Good night. Good night, I'm going to bend up. The guy bara gidi get over there. Gidi get over eh? Guinea standard. Eh, baba buy anything over the Nigeria, over the international standard. They disgrace. I mean, they disgrace maths. Baba, maths is no better than them. Ngom go say about young so say ma fa belen so any question go about the PhD, go about the masters. Go na fa nyo ende go bere ga go ben matari. Mo nda ge pa so. Me nda ron so. Ni se na mo yo, ba mo to mo. Me ngi ma ngi so so ndiro wi me mo so mo ga mo le so.
I'm going to 10 minutes.
Eh?
I'm going to 10 minutes.
Are you going to?
I'm going to go on the 10 minutes.
10 minutes hour break.
The 10 minutes 6 hour break.
The wheel.
But it's almost time 10 minutes.
What's the time? You have already used something like that. You go out again. Let them finish food so that when you come, you just sit one down. It's better. All right, now let's see how we can still so we have been able to solve a term independent of x we have been able to solve the term independent of x, the coefficient of x, not only coefficient of x, sometimes I can say find the coefficient of y, the term independent of y. You also equate it to y, because in some cases you have x and y. So just follow what they give and flow. So, what if you have an expansion that has to do with fractional indices? If I have them back in Nigeria, nice. Offensive more. Side. What if you have binomial expansion for negative and fractional indices? Just like what somebody was asking. Or you the one asking whether you have a power that is negative. There's a special formula to that. Even if you use this other formula of binomial expansion, you still get, but it will not be as, as fast as the other one and reliable. You can still use office pin to remove this thing from somebody's phone, from your phone. You can still use office pin to remove, how do you call it? SIM. But you see that thing that the people or the owner of the phone give to you, you cannot compare with office pin. Abi? Yes, sir. So that's how the formula is. The formula of solving any the formula of solving a negative and fractional indices of a binomial theorem is a very special one indeed. It helps you. It's big, strong, and reliable. No, the class must be interactive class. What does it mean? It has a lot of meaning. It means we need to be communicating. Interaction has a lot of things. You can even ask someone else your family in interaction. So I was saying this in order to say that we have a target. The target is to do mathematics, and we are here for mathematics. Very serious business. It's division of labor. And people that are doing media, my job is to do maths. And people are snapping. They don't know math, but they snap mathematicians. So, you never know what it is. Let's do that binomial expansion for negative and fractional indices. I need to carry everybody along. That's the spirit of learning. Because if you don't carry people along, it's not easy. So let me position myself well if you want to snap me. So please, let's fix up the formula to guide us respectfully. If you have a binomial expansion for negative and fractional indices, you are going to have something like this. Life is beautiful, man. Whatever thing that does not distract you, let's proceed. That thing I'm giving that person joy. Let's proceed. Binomial expansion. Binomial expansion for negative and fractional binomial expansion for negative and fractional indices. Off camera. So the binomial expansion for negative and fractional indices. And energy get on. So man, I'm giving I'm good him. Send go as well. It was a Dwamian bomb. Binomial expansion for negative and fractional indices is what we want to discuss. And this happens when n is not a positive integer. The binomial theorem when n is not a positive integer, the binomial theorem when n is not a positive integer, is given by 1 plus x to the power of n equals to 1 plus nx plus n into n minus 1 factorial all over 2 factorial x squared plus n into n minus 1 into n minus 2 factorial into 3 factorial plus, this is valid for x greater than 1. So, I'm going on about getting even Giddy. I'm not going to have an content. Oh, no, maybe I got my vision. Maybe I got my vision here. I'm playing with you. Last one. Oh, Baba, you get him. All right, now look at this. Look at the formula we are using here to solve when we have a negative power or a fraction. I see it's very sweet. No matter how the stuff is, you can. Let's everybody stand. Everybody stand. Everybody stand. Let's do like this. Let's just do like this. Let's do like this. I'm not seeing you doing it. Do like that. Raise up your hand like this. See, do like this. Oh, yeah. I'm not seeing you, you are not doing like that. Just straight. Do like, see. Hello, do like you. All right, sit down. Let's get them, but my yaga use more. Go. I'm asking her. Okay. Now we want to solve an equation using this formula. I hope you've written the formula down. It's valid for this. Valid for this. X greater than minus 1 less than 1. So let's see how we can use it in our mathematical daily endeavors. The great mathematician, man. If they ask you to solve an expression of, let me say, they say expand x plus y. They say expand 1 plus x to the power of 1 over 2 to the 4th term. You see, they say expand, this is the formula you are using. So what you now do there is that you now say that 1, in this case, what is my n? 1 over 2, abi? So now put it there, and you have 1 plus, what is it? As in 1 plus x to the power of 1 over 2 equals to 1 plus 1 over 2, that's my n, abi? X. Plus what? 1 over 2 into 1 over 2 minus 1. Have you seen that? Okay, have you seen what? How do you call it? Victoria. You don't go factorial, I don't factorials. You don't think about it, never mind me. I just want you to ginger yourself. You said it very well. We're just trying to ginger so that you don't. I want you to be in my page. Now 1 over 2 minus 1. Have you? Look at that. This one now. Then this one is factorial now. Divided by what? 2 factorial x squared. Have you? They say to the 4th term. This is the first, second, third. To the what? Expand this to the 4th term. 1, 2, 3. The last one is what I want to do now. This one is just formula now. If you want to calculate 1, 2, 3, 4, this is still 4th term. It's continuous. If you want to do again, n into n minus 1, n minus n, you understand? You are looking for 4th term to the 4th term, not the 4th term. Expand to the 4th term. That's what I've already said. I'm going to what baby is this? Now, don't 1 over 2, into 1 over 2 minus, are you following me now? 1 over 2, n minus 1, n minus 2, all over what? 3. That's when you stop. 1, 2, 3, 4. We stop there because that's the 4th term. X cube, yes. So we now do the expansion. If I leave from that place, you can complete it for me. And just, let me sit down smaller. energy. Let me small. So we expand that. We expand that, we are going to get what we are looking for. So that point we have so from that point we have 1 plus 1 over 2x plus 1 over 2. I have minus 1 is what? Minus, so you know that? See, this thing, there's no factorial here. There's no factorial there. This place, there's no factorial, there's no factorial. Then you have over 2, factorial is 2, x squared plus 1 over 2. I have minus 1 is what? Minus I have minus 2. 2 times 3 is what? 4. 1 minus 4. Minus 3 over 2. X cubed. Over 3 factorial is 6. One over 2x plus 1 over 2 minus 1 over 2. No, it's just like 7 over 1. So you invert. That will be times. I take this one up. Twins. Be with me in paradise. Plus 1 over 2 minus 1 over 2 minus 3 over 2 times what? 1 over 6. Have you seen the way I do the preparation of the... So everywhere will stew. So from that point, okay, you need the, listen. I did with you. 180 in targets. In that 180. That's your. So we have that this place will now be 1 plus 1 over 2x minus 1 over 8. Okay? X squared plus something can cancel something here. 3 disgraces 2. Maybe? Do we have any minus? Minus and minus is plus. Plus what? 1/16. X to the power of what? 3. Wow, mathematics is beautiful, man. Look at the beauty. Look at the arrangement. Eh? It doesn't lie. You see the thing just come out. Eh? You see the X, see the square, see the cube as it goes. You want to factorize? How? When? How? Why? How do you want to factorize? What is common here? This one is not common to here now. It's only if this place was starting here. Maybe you say 2 is common. 1 is not have a factor now. 1 is a universal number. Eh? It's common to none. So, that's the answer. I feel like solving more. The Bible says, fear will not kill the body, but cannot destroy the soul. So my mother is killing my body, but my soul of my mother is still there. All right, now we've been able to get the linear expansion of a negative value. Even if this place is negative, you see flow the same frequency. In fact, this fraction is hardest than negative. This is just minus 2 minus 1, minus 2 minus 2 minus 3, you know. So anything you see, don't be intimidated. Today is for binomial theorem. I will solve every problem in this world in binomial theorem. Every problem. Because the only thing solution for this life now dates. So it's not doing business with you. Let's see how we can solve another example. If you have let's see how we can solve this. It says find the cubic. If you observe, while solving this, this place is 1. Whatever question they give to you, that has to be a fraction. Make this place to be 1. So it can flow. Shine. Brain box. You don't devote me na mera moyo do. You don't devote me na mera moyo do fian. Aziro afibo it mo boy te me na mera moyo do. Eh? All right, let's proceed. If you want to have all right, So let's just see what we can do to expand something complicated than this. Find the cubic approximation to the expansion of find the cubic approximation to the expansion of find the cubic approximation to the expansion of 3 plus 2x expansion of 3 plus 2x to the power of minus 3. Now remember that expansion we did. This place was not, it was 1. Abi? The place was 1. But there is a way you can make that place to be that value. So let's see what we can do. So you can agree with me that this 3, for you to make this place to be 1, that you have to bring a common factor 3 out. Abi? Come here, my God. You call him for me. Giddy. What is cubic expansion? You need to make this place to be 1. Okay? So that if you divide this place by 3, 3 over 3 is 1, okay? So you take it out. Make it common. You now write this place as 2x over 3. Is it the same thing as here? Is it the same thing? Are they the same thing? If I multiply this, I'll get this back. Multiply this will cancel out, return back to that. Okay? So from that point, I will split this so that I have 3 to the power of minus 3 out. And I have the other one out. So that from there, I keep the other one and I proceed in solving the other inside. You don't want me that this minus 3 covers this and this. Is that right? So that this will now be what? 3 to the power of minus 3 into 1 plus 2x over 3 to the power of minus 3. So this one will wait while I treat this one. Then the result, now I'll join with this and expand. Let's have everybody stand, everybody stand, everybody stand. Let's be on our feet. Let's be on our feet. It's time for question. So you stand, madam, stand and ask question. There's no problem now. So long as you can get, if you are sure that you are getting the answer, use whatever in this life that can give you happiness. You understand? So long as it can give you, because I've never tried that. But I believe that so long as the formula that leads to the solution, you have the correct answer. Do you understand what I mean? Yes. Because the other one is still the binomial expansion. I think it's possible to get, you can still get the answer. But do you understand this question? Okay. Ask about the way you are young. Please, ask the question again.
I said that it is a binomial expansion for negative and fractional index. What if we change the fraction to decimal, then we use the last format that we
General normal method. You still get the same answer now.
binomial expansion to solve. Whether we will still arrive at the
You still arrive now, very well. Most times you normally use that one, say for this fraction. Huh? Most times you use that for all right. So please, I want to believe that if you use that formula, you still get it. Are you getting me? Still get it. If you use that formula, you still get it. This one is just for convenience, but if you use that one, because I remember, we've tried that before, and I remember now, when we were doing some research, that answer came out. Giddy, that's the one I've remembered. I mean, I student, go on get the signboard. All right, any other question? That my friend there with Jesse. That my friend with Jesse. You have question? You were looking for a lively class, so now you are leaving us behind. No, it's not, it's something, in life, even though you hide. No, it's natural. You need to fight for it. Fight against it. Fight against it. All right, please, just do your hand. Let's just stretch. Just stretch. Just stretch your body. Let's. All right, I believe the time is up. So sit down. Let's. Very soon we break. In less than 4 hours we have break. 4. Sit down. That's a comic relief. Sit down, let's proceed. All right, now let's. I have been able to use this cubic approximation to the point that I fixed it up as the one I was expanding. And so with this, I'm good to go. I'll keep this, I solve this. The answer, I take it up. So we want to expand this now using the binomial theorem. So 3 minus 3 will stay. I take this one up. I expand. 1 plus 2x over 3 to the power of 3 to the power of minus 3. So, remember the formula. The formula states what? 1 plus nx. Have you? So this will give us to 1 plus. Let me use this place so that it is special. 1 plus n. What is my n now? What is my x? 2 over 2x all over 3. Beautiful. So that will now be nx minus 3 into 2x over 3. Abi? Are you following me? What's the next step? Huh? Plus what? Plus minus 3 into minus 3. Minus 3 minus 1. All over what? 2 factorial. Did they specify the number we are stopping? Huh? Cubic. All right, now, do we have to write this one, x squared? This place x squared. 2x over 3 squared. Abi? Is that correct? Yes. Plus, what's the next one? Huh? This is to the power of 2 now. This is squared. The next one will be the cubic. Eh? Yes. You don't understand what they call cube. Cube is 3 now. You're just thinking. But what you can think and not bring results. You have to do your needful, even though you are thinking. Everybody thinks. Eh? So, what's the next one there? Minus 3 into what? Minus 3 minus 1. Minus 3 minus 2. Eh? All over what? 3 factorial. Abi? Now, we now do what? 2x over 3 to the power of what? Cube. That is a cubic. Are you getting me now? So at that point, you see, the question is, the arrangement is very nice. We can now flow with that. We can flow with that. Easily we can bring this down. 1 minus. Can this cancel out this? It's possible, right? To make it 2x. Is that true? Now let's go. Minus 3 into minus 4. Minus 3 minus 1 is minus 4. Is that true? Now, we expand this squared. Don't forget 2 factorial is 2. 2 times 1. Eh? Now, this square covers this and this. Eh? That my guy there. Does it cover? Yes or no? Does it cover? Yes or no? It cover. Now, this is what? 4x squared all over 9. Because it covers numerator and denominator. Then, we have finished this place. So. Then, plus minus 3 minus 4. I mean, minus 5. What is 3 factorial? 6. 3 times 2 times 1. Now, what do we do here? 8 what? 8x to the power of 3. 2 times 2 times 2, I mean? Divided by 27. Is that true? 3 to the power of 3 is 27. Eh? Now this is going to be 1 minus 2x. Can this cancel out this? Yes, of course. Eh? Can 3 cancel 9? Very possible. How many times? 3. Eh? Minus times minus what? Plus. Where? Where is the 2? Is it this one? And we use it, we're using to cancel this one. This cancel this 3 times. Eh? We cancel this one too, have you? Okay, so minus minus is plus. That is plus what? 4 times is what? That's 8x squared over 3. Is that true? Giddy? Is it true? Now, can this cancel out this? 3 cancel 6 how many times? 2. Abi? 2 cancel 4. How many times? 2. Now, what do we do next? Minus cancel minus. What minus will remain? Is that true? So we have minus there. 2 times 5 is what? 10 times what? 80. Minus 80. X to the power of 3 all over 27. Can anything cancel something here? You cannot cancel now. There's no. I have to finish the inside now. That's the beauty of mathematics. If I don't take it to the other one was waiting. You have to wait. There's no room for mistake in maths. Any mistake, your answer is wrong. That's why I tell you that mathematics always talk true than any other thing. Because when the result comes out, you see. Praise the Lord. So this place now, look at this. The answer we have here was remaining 3 to the power of minus 3 down. 3 to the power of minus 3 is what? What is 3 to the power of minus 3? 1 over 27. Is that true? Yes, sir. So therefore we can now say, I'll blast my guy, 3 to the power of 3 is what? 3 to the power of 3 is what? 9. Beautiful. So this place will now be 1 to the 1 over 27, Abi? Yes, we now open the bracket. Abi? Yes, you now open the bracket, this is 1 over 27, Abi? Minus 2x over 27. Is that right? Yes, this multiply the down, not the up. Huh? Plus 8x squared over 81. Beautiful. 81, yes. That's typing error. Minus 27 times 27. 729. That's my expected answer. 80 over 729. Because I see every answer in the spiritual realm before I start solving. That's my expected answer. So that's 1 over 27 minus 2x to the power of 27 plus 8x squared over 81 plus 8729. Yes, that's the answer to any court of law. That's the answer. To any court of law, that's the answer. Professor. Professor. So I make it. Can you give? Can you give? 10 minutes. I might answer like 4 questions. So I'm going to solve one more question before we go for break. Need to go and relax, eat, feel at home, come back for the next 15 hours. So, that mathematics is very beautiful.
Yes. The math mathematics is so beautiful.
Yeah. So copy that so that we can proceed. My friend, don't worry, everything will be all right. My prayer request for you is great. If you divide 150 hours, if you subtract you see, if you divide 150 hours by 3, 150 by 3, do you know what you have? 50. This thing is close to 50, so we are at the 2/3 of the movement. So you don't have to be intimidated. Just you are at the bridge of no return. All right, now let's proceed. This math is very nice. I love it. I feel like standing in the background and snap. How can I clean? I'll clean this side. Okay. You guys are clowns. All right, now the next question. There's a question that is always very nice here. It says evaluate. Evaluate 1 plus the roots of 3 to the power of 4. Now, let's evaluate this using binomial theorem. Huh? It's not compulsory that I even solve itself. I can come solve it when I come back. It's not compulsory that I must solve it. I just want to keep the question. If you do one side, you can do the rest. If you observe very well, you see that one thing about math, anytime you see math, think of what to do. If you expand this binomial theorem to the power of 4, if you clear one side, the other side is a plus, one side is a minus. The same answer, just when you see a plus, you put a minus. You join and something will cancel something. You get the game. The mathematics, just think, see, mathematician doesn't solve math immediately. There are sometimes someone will give me math to solve. I'll just look at the math. I don't know. I'll go and think. Then come back to solve. So you think. So what do you think? You know that this question here is binomial theorem. Just with Pascal triangle itself, you can get the coefficients. Put it 1 to the power of this thing. Something will cancel before you know you get the answer. You understand what I mean? So now let's see what will happen there. Let's start the solving. Baba, are you true? I still drawing. I finished. Okay. Now, we want to solve this. Recall that this is 4. So we take 1 plus root 3 first to the power of 4. Keep 1. Because what it says here. Now, this is 4 combination 0, 4 factorial. 1 to the power of 4, root 3 to the power of 0. Abi? Is that true? Plus 4 combination 1, 1 to the power of 3, root 3 to the power of 1. Abi? Is that correct? Yes, plus what? 4 combination 2, 1 to the power of what? 2, root 3 to the power of what? Is increasing. This one is increasing, this one is reducing. Plus 4 combination 3, 1 to the power of what? 1, root 3 to the power of 3. The last one, 4 combination 4, 1 to the power of 0, root 3 to the power of 4. It started with 4, ended with 4. Okay? Yes, sir. Are you with me now? Yes, sir. So from that level, we know that what is 4 combination 0? 1. Abi? Okay? 4, what's 4 combination 0? 4 combination 0 is. So this one, all this place is 1. Any number to the power of 0 is 1. 1 to the power of 4 is 1. Plus, what is 4 combination 1? 4. Root 3. Abi? What is 4 combination 2? Check your calculator and punch. 6. 6. Now, this is root 3 is gone. Are you aware of that? From the law of sort, root 3 times root 3 is gone. Abi? Yes. That is, we did sort yesterday now. Yes, sir. Yes, sir. Brain box. Is it correct? What is 4 combination 3? 4. This one, root 3 times root 3 times root 3. That will be what? 3 root 3. So this place will now be 3 root 3. What's 4 combination 4? This one is now what? Root 9. The 1 and 3 become 9. So now this place will now be 1. 1 plus 4 root 3 plus 18 plus 12 root 3 plus 9. So you observe the same question that it says is this side. Just that one is side plus and one is what? Minus. So if I now bring it together, this is what I will have. I will have 1 plus 4 root 3 plus 18 plus 12 root 3 plus 9 minus the same solving of this. One side will be 1 minus 4 root 3 plus 18 minus 12 root 3 plus 9. That's how anytime you have a minus sign in expansion, it's a plus, minus, plus, minus, plus, minus. So this is going to give us 1 plus 4 root 3 plus 18 plus 12 root 3 plus 9 minus 1 plus 4 root 3 minus 18 plus 12 root 3 minus 9. So something will cancel something. Okay? Hmm? One minus one is gone. 9 cancel 9. Where's 18? Any other thing? All of them announcing me last word. All of them announcing me last word. That's the last word. You add 4 plus 12 plus 4 plus 12. What is the answer? 4 plus 12 is 16. 16 plus 4, 20. 20 plus 12. That will be 32 root 3. That's the answer. Clap for now. The time is okay. Please, how long? How long are we staying? 10 minutes. 10 minutes. I'm going
that media, can we use the next 5 minutes? Or
I'm not going to 5 minutes. I'm going to eat them and I'm going to eat them down.
okay. So the audio, once we leave this place, time is counting. That good time. So can I'm good.
And let them go do their work bath now and come back on next time. I don't know. Eh? And I will eat them and change of my word. I'm going to do the process.
Okay.
Dismiss. All right, please, let's go and try as much as possible to see. You can go and, if the food might not be ready now, you can bath and come down so that you can manage your time. Eh? 10 minutes, you can still manage. Let's just see how it goes. If you cheat your time, you still cheating the time you want to sleep.
Man, I've been fighting this battle with demons inside of me. I just won't stay in my lane so nobody can bother me. Bitch, I'm too sensitive, intimate, touching me ego. Thought I had niggas and someone told me how they go ride for me. All along, all of them be jealous. Fake souls always make me nervous. Out of here, bitch, I'm on my peppers. Pull me down, still I'm breaking records. I'm on 1,000, but they wanna take me to 0. Fearless nigga, only God is my hero.
Let your angels cover me every day, cover me every night. No take no one else. I'm on the top and I keep on winning.
Yeah.
Higher.
Okay. Okay, student, all the students, Brembos. Okay, student, I get my already on the phone, girl. Okay. Like, it's complete now. Okay, we're complete. We are back. And we were still on binomial theorem. Still on the binomial theorem, we were able to do the laws, Pascal triangle, the R1 term, and the binomial expansion for negative fractions. So we want to talk about binomial expansion and approximations. Binomial expansion. And approximations. Now we have some questions that in binomial that will be approximated. So we want to see how we can solve them. Those questions are not far-fetched from us. Like, this question, they say, obtain the binomial expansion of a plus 2b to the power of 7. Obtain the binomial expansion of a plus 2b to the power of 7. Example 1. Obtain the binomial expansion of a plus 2b to the power of 7. Hence, evaluate 1.02 to the power of 7. So for significant figures, so look at that question. You see, if we obtain the binomial expansion of that, we are going to have a certain value to the power of 7. And then from that point, we will now substitute the value that was given in the expression. Let's see how we expand that binomial expansion first. Solution. A plus 2b to the power of 7 A plus 2b to the power of 7. Now we know very well that A and 2b takes the place of x and y in the expansion. And so the coefficient of it starting with 7 combination 0, A to the power of 7, then 2b to the power of 0. Are you following me? Yes, sir. Now what's the next step? 7 combination 1. 7 combination 1. A6. 2b1. Maybe? Plus 7 combination 2. A5. 2b2. Plus 7 combination 3. A4. 2b3 plus 7 combination what? A3 plus 7 combination 5. A2 2b5 plus what? 7 combination 6. A1 plus the last one, 7 combination 7. Plus 7 combination 7. A0 2b7. You see, it starts with 7 and ends with 7. While it's starting here with 0 and ends with 7 up. And the power is increasing from 7, 6, 5, 4, 3, 2, 1, 0. While the power of 2b is increasing from 0, 1, 2, 3, 4, 5, 6, and 7. Is that clear? Sure. Then we all know that 7 combination 0 is what? 1. Any number combination 0 is 1. So that will be equals to A to the power of 0, because 2b to the power of 0 is 1. Plus 7 combination 7 is 7. 7A6 2b plus, what is 7 combination 2? Remember straight. Eh? That's 21. A5. This square covers everything. That will be what? 4b squared plus 7 combination 3 is what? 35. A4. 8b to the power of 3. Are you following me? Plus 7 combination 4. 35. A3. 16b4 plus 7 combination 5. 21. A2 32b5. Is that true? Plus 7 combination 6. 7a, then 2 to the power of 6. 64b6. 7 combination 7 is 1. Any number to the power of 0 is 1. So that will be 128b7. Is that clear to all? Yes. So from that point we have a to the power of 7 plus, you multiply 7 with 2, what do you have? That will be 14. A6b. Is that right? Yes. Plus 21 times 4. 41484. A5 b squared. Abi? plus 35 times 8, 280 A4 B3 plus 35 times 16, 560, right? A3 B4 plus 21 times 32. 21 times 32. 672. A squared B5 plus 7 times 64. 448 AB6 plus 128 B to the power of 7. So we've been able to succeed to expand A plus 2B to the power of 7. And then the B part of that question was to evaluate 1.02 to the power of 7 and to force a significant figure. So if you now check that value, you see that 1.02 can be written as 1 plus 0.02. Is that true? Coming over here, we have that 1.02 to the power of 7 is equivalent of saying 1 plus 0.02. If you add up this, you get this. Is that true? To the power of what? 7. And now, if we compare the value of what we have here with that place, is that? If you compare this, comparing A plus 2B to the power of 7 equals to 1 plus 0.02 to the power of 7. You can agree with me that this is this and this is that. Abi? So therefore 2B equals to 0.02, Abi? Is that correct? So therefore B will now be what? 0.02 divided by 2, which will give us 0.01. So that place B will be equals to what? 0.01. So that it is just like saying 1 plus 0.01b. So we are going to put it as is equivalent to 1.02 equals to what? 1 plus 2 into 0.01 to the power of 7. This is the same thing as here. Have you seen that? It don't mean that wherever we see the value of B, what do we put there? 0.01. And A, 0.01. A is 1, yes. Please copy that. Let me explain again before we proceed. Copy. So you see that immediately give you a value for you to solve or to expand using binomial expansion. We know that this symbol stands for binomial theorem. And it is incumbent upon ourselves to solve it respectfully. All this A to the power of 5 to the power of 5, if you multiply, we want to see have the same thing. So when we put 1 here, Just for us to target and put our B. Huh? And get the last. So that will be 1 plus 14. What is my B there? 0.01 plus 84. A is 1. 0.01 squared plus 280. 0.01 cube plus 560. 0.014 plus 672. 0.015 plus 448. 0.016 plus 128. 0.01. So you can use calculator to press and get your value. Use calculator and punch. Let me get the answer. Press this plus that plus this. One point one four. 1.1484. Another answer. Another answer. $1.1487. Another answer. It's not. This is the question was A71. Now the question was to put it in 4 significant figure. In 4 significant figure. So if you want to put it in 4 significant figure, this is 1, 2, 3, 4. 1, 2, 3, 4. 1.149. So maybe you have approximated something here. But this is the one I see in the book. This is the one I see in the book. I saw 1.149. Approximately 1.149. But even if you write this, they'll still mark it for you. But let me follow the one I see in the book. So we've been able to get that value very well. So that is how we solve that approximation of values. Now let's try some other one and see. The one that contains fraction. The one that contains fraction, let's try that one and see. I hope you're through with this. Just leave the eye. All right, let's try the second question. I know what you can do. I know my sheep and my sheep knows me. You take time to write. You don't rush. Have you? It's good. That's a work of a mathematician. Now, example 2. Show that the root of 9 minus 18x is approximately 3 minus 3x minus 3 over 2 x squared minus 3 over 2 x cubed minus 15 over 8 x to the power 4. Four. X greater than minus 1 over 2 less than 1 over 2. So let's see how we can solve this question. Show that this question that I gave to you here is binomial theorem. Then the B part of the question, this is I. This is I. I. Hence, using the above approximation, evaluates the root of 3.6 to 2 decimal places. That's a very nice question. I like questions that are so technical. So what we do there is that you say, show that you are going to solve this math to funny and until you get that one. I follow me. So, but for now, you now substitute this into that equation. So what we do there first is to see how we can, because recall that before you solve the value of x that is greater than this and less than this, it is a function that have a power of n less than 1. That range they gave there is less than 1. Is it true? Good. And even before what you see that this place is square root. But there are some challenges there because there's no 1 here. Are you getting me? But if you see it critically, I think we can deliver. I mean, through God has strengthened us. Hallelujah. So I believe you are through with this side now. So at this point, we now bring out the question. Solution. The question is the root of 9 minus 18x. Now look at this. Between 9 and 18, I can see something that is common. Have you observed? Yes. What's that? 3 is common. 9 is common here and there. To make this place 1. Eh? Is that true? Yes. So we can now say this is equals to the root of what? 9 into 1 minus 2x. Is that true? That is very possible. Eh? And from the law of sort, we can say this is the same thing as saying root 9 times root 1 minus 2x. Is that true? Yes, sir. Huh? Yes. Now root 9 is what? 3. So I can say this is what? 3 root 1 minus 2x. Is that accepted? Yes, sir. And from the law of sort, this can be written as what? 3 into 1 minus 2x to the power of 1 over 2. I mean? So with that, we are good to go. Eh? We are very good to go. So now we now bring it back and say this is going to be 3. The 3 will stay outside till we finish our expansion of 1 minus 2x. Because at that point now, we can use our law of expansion very well. Whereby, remember the law of expansion. The law state is going to be 1 plus, what do? Yes. 1 plus, what else? Our power is 1 over 2. That's n. nx. 1 over 2. What is x? Minus 2x, I mean. Is that true? What else? Plus 1 over 2 into, that's a half minus 1. That is the power minus 2x to the power of 2, all over 2 factorials. Is that correct? Then plus 1 over 2, 1 over 2 minus 1, 1 over 2 minus 2, all over 3 factorial, minus 2x to the power of what? 3. Now, do you see where they stop their own? This is where you follow them, because you are going to do something closer to this. So you're going to do one more. Abi? That will be what? Plus 1 over 2. 1 over 2 minus 1. 1 over 2 minus 2. 1 over 2 minus 3. I think that's the way forward. Then into what? Minus 2 x to the power of what? 4. We are closer to the all over 4 Victoria. Is it Victoria or Factoria? So at that point, we can now rearrange before you can now split. The 3 will wait until we finish what you have inside. Abi? So this place will now be 3 into 1. This can cancel out this immediately. Abi? Minus x plus 1 over 2. A half minus 1 will be minus a half. Is that right? What do we have here? 4x squared. This is 2 factorials divided by, you can invert. 1 over 2. That's correct. Plus 1 over 2 here. Minus 1 over 2. This is 4 minus 3 over 2. This is going to give us no minus here again. 8 x to the power of 3 times 1 over 6. That's the factorials. Now, plus 1 over 2 into this place will now be minus a half. But the minus a half is minus 3 over 2. Then minus 5 over 2. 16 x to the power of 4. 4 factorial is this x over 4 times 1 over 24. That's a very nice one. So the next step will clear off everything. Okay? So this will be 3 into 1 minus x plus, this one is up. This is up. Okay? So 2 can cancel itself, 2. 2 cancel here. Is that true? So this is going to give out minus, there's a minus here. So we turn the minus. Then any other number up? No. There's nothing there now. Minus 1 over 4 here. There's x squared. So you can see 3 here, you can see 3x. This 2 cancel now. There's no 2, it's 2. This one cancel now. This one was using the cancel this one. Was it not this one that cancel this one? So I'm trying to picture what I have here with the answer. You understand? You know, you have to work with your answer and so that you be sure of what you are doing. So, plus this place here, there's a 2 minus here. So you turn to plus. Now this one is up. This one is up. Have you seen that? So 2 can cancel 8, 4. 2 here. Do you have 2 here, right? Cancel this. 2. 2. Cancel this 2. This 3 is up and 6 is down. Is that correct? 3 cancel is 7. Cancel how many times? 2. You have another one. No other one. It's only 2 that's remaining. So that will be, and there's x cubed there. So that will be 1 over 2 x cubed. Have you? Which one? There's a minus coming out here. There's a minus here, so this place will be minus. But every other one is correct. Abi? We are good to flow. So this is the last one. All of them are together. Abi? So 2. Which 2 here? 16 is up. 3 is up, can cancel this one. Have you? Is that right? Let's start with these 2. 2 cancel 16. 8. Can 8 cancel 24? 8 cancel this 3. 3 cancel 3 here. You have another one up. So the number down is 2, 4. 2 times 2, 4. 4 times 2, 8. That's 8. I see the 8 reflecting there. Minus, we cancel 1 minus. So minus will remain. Abi? That will be minus 5 over 8. Then x to the power 4. I think we have been able to do that very well, and the thing has come out, no matter how complicated it was, in a grand style. Mathematics is fun. Eh? So what do we do here now? We have to multiply the 3, okay? So this is going to be 3 minus 3x minus 3 over 2x squared minus what? 3 over 2x cubed. Now multiplying this 3, we have what? 15 minus what? 15 over 8x 4. Check whether we have proved that, they show that this equals to this. Are they the same thing? Yes. 3 here, minus 3 here, minus 2 over x squared here, minus 3 over 2x cubed there, minus 15 over 8. So we have proved that first one. Now remaining us to, they say hence, using the above approximation, evaluate this. So copy so that we can finalize the business. Mathematics always talk true. If there's no truth, the thing will not come out. So, mathematics cannot lie. If you lie, the answer will not come out. There's no manipulation. You cannot forge. Can forge anything, not math. So when we now do that, we now see how we can simplify 3.6 so that we can now have that value. 9 into 1. Please copy that so that I can. 9 into 1. Yeah, I'll be 9. So at that point we see that we have been able to get that value of that root. Then we now target what is what targetable. Now target what is targetable. Targetable of that value. So let's see how we can fix up that 3.6. Let's see how we can fix up that 3.6 so that we can do justice to that mathematics. Come to think of it, what is the relationship between 3.6 and 9? You have to see how we can make those two of them look alike. You need to create something that make them look alike before you even think of the factors of 3.6 that is related to 9. We can divide 3.6 by 9 first and see what will happen. Are you getting me? Whether we have any characteristics of that value. What do you say? Does it have any relationship with 9? And let's check. So, we've been able to establish that relationship that this is equals to this without any fear or favor. Perjury or ill will. Is that? In mathematics, just take care of the minutes, and the hour will take care of itself. So, we have now established a relationship that 9 minus 18x equals to 3 minus 3x minus 3 over 2 x squared minus 3 over 2 x cubed minus 15 over 8 x4. Now the question was, hence, using the approximation, evaluate the roots of 3.6. So you now see how we can compare this 3.6 to this relationship. Let's do something like this. Let's just say 3.6 divided by 9. Just press, let's check. Press 3.6 divided by 9. 0.4. So therefore, we can now say that 3.6 is the same thing as saying the root of 9 times 0.4. I mean, something like that. Is that true? 9 times 0.4 is 3.6. At the same time, since our relationship, look at the way we were solving it in such a way that we have something like, when we were solving this, we have something like this. 9, we had a equation, the thing was like 9, the root of 9 into the root of 1 minus 2x. We have something like this. So we can present this in this form. Abi? We can present this in this form. If this is 9, 3.6 is this. What if we say, this same thing as saying 9 into 0.4. Abi? Now this is the same as saying 9 into 0.4 is the same thing as saying 1 minus 0.6. Is that possible? Check. 1 minus 0.6, is it 0.4? So what if I said that 0.4 is 1 minus 0.6? Am I wrong? So you see that I'm trying to get closer to this guy. Trying to create a relationship now from 3.6 that were given to me. Because if you don't have a relationship of what they give to you, you cannot start, so you cannot forge. So at that point, if we compare this with this equation now, see, they look alike. They look alike. So this equals to this, Abi? Is that true? This equals to this. This equals to this. So therefore, we can now say 2x equals to 0.6. And now x will now be what? 0.6 over 2. Can we get 0.6 over 2 is what? Is that? 0.3. So we can now say this is the same thing as saying the root of 9 into 1 minus 2 into 0.3. As I'm trying to create a relationship here now that look like this guy. So this place can be written as 2 into what? 0.3. So they now look alike. Exactly. So when they now look alike, now you can now call this x 0.3. Have you? So you now call this 0.3. So you now say, from the relationship now, x, this x we are looking for, equals to 0.3. We now substitute and get what they are looking for. Is that correct? So, whatever we say is put 0.3. So let's do that. Put 0.3 there and multiply. Let's get the answer. They say 2 decimal places. 2 decimal places. One 1.9093. Is that 2 decimal places? That's 1.90 now. Yeah. 1.90. That will be 1.91 now. $1.9. Okay, now you can say 1.90. 1.90. A zero after a zero. Eh? A zero after the decimal place of 9 is not included. It's not counted as sir. 2 decimal places. 2 decimal places, not 1. 2 decimal places. Uh. 906 is the decimal place. So we can present our answer by saying, for the II, to summarize, that 3.6 equals to 9 times 0.4, which is 9 into 1 minus 0.6, which is 9 into 1 minus 2 into 0.3. Therefore, taking x equals to 0.3, 3 minus 3 into 0.3 minus 2 over 2 into 0.3 squared minus 3 over 2 into 0.3 cubed minus 15 over 8 into 0.3 to the power of 4 is equals to, what do you say is the answer? 1.1? 1.90. So that's the answer. This math is very nice. I like it. Fangirl, do you understand what we are doing here? Record breaker. The longest student. So that is how we solve that. That's how we solve that math. So let's check another. Let's check another example. I hope I can clean this off. Example 3. You see, binomial theorem, the way it's presented, some people believe it's very difficult. But now I want to go into some tutorial questions in binomial theorem, the evaluation. Evaluation. This morning we do binomial theorem. And we have crossed all the T's and not all the I's respectively. So let's do evaluation before we enter another topic. Evaluation in binomial theorem. Evaluation in binomial. Now the first question we want to solve. Expand 1 over the root of x minus root x What's that? Eh? Expand that. Now from Pascal triangle, give me the values of the coefficient of power of 5. From Pascal triangle. 1, 5, 10, 10. 1, 5, 10, 10. You see this question? They say expand. Have you heard anything about binomial theorem? Eh? Expand. Huh? And when they say expand, you can use anyone. Unless they say using binomial theorem. You understand what I mean? So we can use this one. We are good to go. So from that point we have that this is solution 1 over the root of x minus the root of x equals to 1 over x1 over 2 minus x plus minus so we now have to see how we can remove that square root. It's possible, right? This is x is 1 over 2. You can still keep that and multiply. You see the same thing. So we can just multiply and have that particular answer. So let's see how it goes. Let me just start expanding it one time. Solution. Coefficient is 1 here. 1 over the root of x. Then to the power of 5 minus root x. Abi? Huh? Minus 1. You see the same thing. This one can clear off one term. Plus 5. Even if I do like that, I will still get the answer now. So no, 1 over root x into 4 minus root x to the power of 1. Abi? Is that right? Is that correct? What's the next one there? Plus 10.
Plus 10 into 1 over x.
1 over root x to the power of 3 to the power of 2 plus what's the next one there? Another 10, right? One over root x. Is that so?
Yes, sir.
Then minus root x to the power of 4 plus the last one. Anjira baru darah dia. So therefore we have this is 5 of this. So 1 square root will still remain. Abi? Can we do like that?
X squared with X.
No.
1 over
X times X. This will go, this will go.
X squared with X.
Okay?
1 over
1 over X squared root X. This one is gone. Plus 1 over X squared. I mean, yeah. Can put minus 5 here. Abi? Into that is x root x. This one will come and cancel this one. There will be no minus here again. Yeah, let it be on top here. Don't let it be like that. And the 1 over x. That will be, huh? That will be here minus x root x. This one will be x squared. So we've been able to simplify that to that level. So the next step will simplify it more. This is like this now. 1 over 2. This plus We add now. Let's just add this one time now. If I add this, I will have x plus. Let me learn how to make it easy. Let's cancel this. There's a minus me now. Eh? There's a minus here now. This one. Where do you have a minus? Okay, this one cross up. 1/2 minus, yes. So this one will now be me plus. I can put it like this. This will cancel out this. That will be minus 10. X to the power 1/2. Abi? Minus a half. Abi? Minus x squared. Have you seen what I'm doing there? So that will be 1/x. That will be minus 3/2. Minus 10 x to the power of a half. This is 4 minus 1. Can we present all like this? Those ones that are down, take it up. We don't have anything in common. You don't have. All of them are different. All of them have different things in common. Plus 10x minus a half. Plus 10x a half. That's the stuff. Huh? The box. That's okay now. It's nice. It's fun. So we have been able to have that value of they call Sokatwa, which is sine, cos, tan, and lots more. So coming back to what we've done, let us start from the basic trig ratios that we have. We have the sine theta, we have the cos theta, we have the tan theta. And now, you also have the cosecants, the secant, the cotangents, and lots more. So ability for us to still hold lies on ability for us to do what? So please, let's take a look at the major stories. If we call that angle theta, if this is A, this is small a, B, small b, this is C, this is small c. So from that angle we see that sine theta equals the opposite we're starting today trigonometric ratios. Opposite of a hypotenuse. All right. Now for the sine is opposite of a hypotenuse. So in this our angle, opposite of that angle is small c. Hypotenuse of that angle is, that's hypotenuse, the longest side. That is the small a, which we are going to have that sine theta equals the opposite. So opposite is C, hypotenuse is A. Take note of that. Now, cosine. Cos theta is adjacent. Remember that thing we talked about, Sokatwa? Sokatwa is sine opposite of hypotenuse. Cos adjacent of hypotenuse. Sine opposite of adjacent. So cos theta is adjacent. Adjacent is here over hypotenuse. Yeah. What do you say? I don't understand what you are saying. You see now, you see. There's no E here now. That is why my hand is covering. So cos theta is adjacent over hypotenuse B over A. And tan theta Tan theta is opposite of adjacent. Opposite over adjacent, C over B. Now you also agree with me, there's what we call secant, cotangent and cotangent. If you say 1 over sin theta, 1 over cos theta, 1 over tan theta, you have special relationship. They have special relationship. What is it?
Three or four people, me myself, I won't go.
Have you told them? Don't tell them.
I say five, something I
What's the time now, sir?
One past 3. Okay, one. This is one.
I will be there at the 5. I can get that. You know, it's better.
All right. So, sorry, even if I'm in this plan, we didn't make any cartel, I don't think something like that.
These people take too much of time. We are in a deficit of 70 minutes. We talk now 70. Minus 70. We are not at the
70 minutes.
So we are in a very difficult situation.
We have been on there.
It's on you. We have already run 34 minutes. That's from break. And it's just in 18 minutes in.
And bombs, because of long bomb, I'm going to do it in a bringing it. No, I'm going to get 30 minutes. I'm not going to get a I can make me chain over. Saying, if you sleep, make me the chain over because if all of them are tired. No, all right, now, as I was saying, we have the trigonometrical ratios I talked about cosine, tan. And I discussed that for sine we have opposite over hypotenuse, which is opposite is C over A. Then cosine is adjacent over hypotenuse, which is for the adjacent we have B as the adjacent of this angle over hypotenuse, the longest side. Then for the tan we have the opposite of adjacent. And for this angle, this is the opposite, and this is the adjacent of the angle. I also said that we have other angles. I will talk about that, the sine 1 over sine, 1 over cos, and 1 over tan. Then 1 over sine is cosecant. 1 over sine is what? Cosecant. So this is cosecant, which is always written as cosec theta. Then 1 over cos is secant, which can be written as sec theta. And 1 over tan is cotangent, which can be written as what? Cot theta. So if you have the special angles, you see that coming back to 1 over sine here, sine is C over A. So coming back to 1 over sine, look at, which is cosec. You can now say that cosec is what? A over C. Is that true? Yes, sir. Because it's a reciprocal of what? Sine. And cos is what? Secant. That is, 1 over cos is what? Secant. Yes. Which is what? B over A. So you can say this one is what? A over B. And cot is what? Opposite of tan. Tan is C over B. So 1 over tan will now make it to what? B over C. So that's the relationship we have in trigonometry. Now, if you see those special value, it is also true that tan theta is equal to what? Is equal to sin theta over cos theta. So let's see. If I have sin theta is equal to tan theta equals to sin theta over cos theta. Let's check from this relationship whether it will come out. If you have tan is what? C over B. Abi? Yes. So let's write it as C over B divided by cos theta. What is cos theta? Eh? B over A. Then, if we reciprocate this, it is true that C over B divided by what? B over A equals to C over B times A over B. Is that true? If you invert, sin theta, where is it? Sorry, C over A here, yes. C over A. So this is C over A. C over A divided by B over A. So this is going to give us what? C over A times you invert A over B. A will cancel out A, abi? So what do we have? C over B. So tan theta is equal to C over B. If you also check here, you can agree with me that tan theta is what? C over A, C over B. And we also have it here, the same. So we have proved that relationship that tan theta, it was what? Sin theta all over what? Cos theta. So let's see how we can also use this to solve some equations or problems in trigonometry. If they give you one side of the angle, you can use and calculate other side of the angle. Assuming they give you sin theta to be 8 over 7. They say find cos theta and tan theta. Sin theta 8 over 7. They say sin theta is 8 over 7. Given that sin theta equals to 8 over 7, they say find cos theta, tan theta, cos theta. You can be able to use that given expression there to find the corresponding value of what we are looking for. You have that equation given, sin theta equals to 8 over 7. Sin theta equals to 8 over 7. First of all, we can sketch that graph. You can sketch the triangle. Now, when we sketch the triangle, we can find the unknown using Pythagoras theorem. Is that true? And we can find Pythagoras theorem. We can now calculate everything that we are looking for. We can calculate everything we are looking for. Any version of what we are looking for can be calculated there. Let's try and see how it goes. Don't forget we are talking about trigonometry. Now, given that sin is 8 over 7, find cos theta, tan theta, cot theta. So first, we have our right angle triangle, given points. Sin theta, you can call this place theta, you can call this place theta, depending on where you want to fix your angle. You should have the same thing at the end of the day. So I call this my theta, this is my opposite. So opposite is 8, hypotenuse is what? 7. Because they say sin theta is opposite over hypotenuse. Sine. So that's what is given to us. And now for us to be able to get other points, I can letter them A, B, C. And then I can also see how I can find this corresponding value, this place, from Pythagoras theorem, right? From the Pythagoras theorem, I'm looking for this place. So AB squared equals to AC squared minus AB squared. I'm looking for this place. So it's going to be this one minus BC. Because the square of the longest side of the triangle is squared the other side, the other two sides of this triangle. So at that point we can find AC 7 squared minus BC let's have this value to be 17. So AB squared will now be equals to, what is 17 squared? 2 minus what's 8? Eh? So therefore AB will now become the square root of 225. 15, I mean. So this place is 15. So long as we get that place to be 15, we can be able to get other values easily. That's the beauty of the business. Have you? So at that point we have first question was to find sine theta and was given, we've seen it. Then cos theta is, what is cos theta? Adjacent over adjacent. Cos theta, this is theta. Adjacent, this adjacent over hypotenuse. We've done that in our. What was the next thing to find? Tan. Tan theta is opposite over adjacent. Have you? Opposite over adjacent. Opposite of the angle. 8 over 15. So this was the first question they gave to us. Cos theta, we've done that. And the next one is for us to find cot theta. Cot theta is 1 over what? Tan. I mean? When I do that, I say, eh? Eh? All right. Now, cots. Eh? All right, please. Tan theta is opposite of adjacent, which is 8 over 15. And cot. Let's see what's going to happen there. Oh, my senior student. So we got that our tan theta is that. So my cots, this was my I, A, B, and C, cot theta. So cot, 1 over tan theta is cot. So we've gotten our tan theta as 8 over 15. So cot will now be what? 15 over 8. We don't deal on decimal points. We don't deal on decimal point there. Now let's proceed. You've been able to establish that relationship very well in cotangent, which is very, very necessary. So, if they give you a question like, you should calculate cos theta plus sin theta minus cos theta, all those ones you can do it very well. Now, let's get another question done, which is the relationship between the ratio, apart from drawing and getting other things being done. Let's get that we know that sin theta over cos theta equals to tan theta. Then let us see how we can get that relationship done. So, there are some basic laws you need to know in trigonometry. It's the 24th of 04. Okay, now let's get this one done. If cos x equals to 5 over 13, find the value Sinama. They gave you cos x as 5 over 13. It's a find the value of sin x over tan x. You have a relationship that sin squared theta plus cos theta equals to 1. This is a little offside. Maybe the young bone. Okay, please, let's just flow. We'll soon be free. Let's just try and do something, please. Let's coordinate. If I'm teaching, you people are not listening, it makes yes. So let us see how we can get that relationship of cos theta, sine and tan. Don't forget that you can still create an angle with this. Okay? Cos theta is 5/13. So let's try build on that relationship. Abi? If I call this angle theta, or let me call it x, as the case may be, x adjacent cos adjacent of a hypotenuse. Is that correct? Yes, sir. So we can now use particular theorem to get this place. Is that possible? Yes, sir. Let me call this A, B, C. Then, from Pythagoras theorem, so at that point we have that AC squared equals to what? AB squared plus what? BC squared, and we are looking for BC squared. So BC squared will be AC squared minus AB squared. Huh? Yes. Is that correct? Yes, sir. So equals to 13. Can I get that? 13 squared minus 5 squared.
We have 169. That is 144.
What's the answer? That's less 144. Abi? So that 12 will now be written here and be used to find other part of the angle. So now let's go back to the question. Sin theta and tan theta is very simple for us to get that. I hope we can do that now.
Yes, sir.
Senior man. You guys are there. Everybody. Times 3. Now my own is times 3. So now let's go to the value for sin x. Sin x equals to opposite of our hypotenuse. Sin x. The opposite of that angle opposite. What's opposite there? What's the hypotenuse? That is an x. Tan is opposite of adjacent. opposite over hypotenuse. That will be 12. That's not hypotenuse now. Over tan theta is opposite. Which is the opposite is 12. All over adjacent 5. So that will be 12 over 5. Exactly. This one is bonus. This one's a bonus. Sometimes I even feel reluctant teaching trigonometry, but you have to do that. Eh? Yeah, you have to. So let's just flow. There will create time for you people to relax. Let's communicate so that at least we can do something in the next 30 minutes or thereabouts. Let's just continue to see what you can do. All right, now since we're able to understand that fact, if you have relationship between the ratio, let's get the relationship between the ratio sine over cos, cos over sine, and tan over tan. The first relationship we have established that sine over cos equals to tan. And also, you can also establish that cos over sine equals to cot. You know that one? I want us to also establish that relationship that sine square theta plus cos square theta equals to 1. That is, if you square sine theta and cos square theta, we are going to get 1. Let's check from this triangle and see whether it's going to happen like that. We call this angle line ABC. And what is sine square theta? Excuse me. So we have to find out the relationship we have with sine and cos. Let's check from that graph or from that triangle. From that triangle we have that sine square theta plus cos square theta is what we want to derive now. Sine theta, as we established, was opposite small a. If I call this angle theta now, sine theta is opposite small a over hypotenuse small b. And cos theta equals to what? Adjacent of the angle. Small c over hypotenuse. Small b. Then let's check sine coincident plus cos and see what will happen. I take this and join it. This is a over b squared plus c over b squared. If I open this bracket, I will have a squared over b squared plus. Now, LCM of this b squared, you have a squared plus c squared. And then from the triangle, we have from that right angle triangle AC squared, B squared, A squared plus C squared. So if you now get that, we say that from a triangle, B squared equals to A squared plus C squared, Pythagoras. So we can put it there, we have so we've been able to get that value there. Who's listening to me in class? I ain't about to say no. Okay, we want to check. So I wanted to derive the relationship that sine squared theta plus cos theta equals to 1. Moment. So you can agree with me that from that derivation, it is equals to side. All right. So from here, I was using sine theta and cos theta to square them and find LCM. But the up of this from Pythagoras theorem will give me b squared. Because b squared, which is this squared plus this squared. So if I now substitute that b squared here at the cancel, I will have 1. Showing that sine squared theta plus cos theta equals to 1. Is that clear?
Exactly, sir. Correct.
So, oh, wow. We also have that relationship that if you can use sin squared theta to derive other relationships. With this, we can use it to derive other relationships right away. Now, it has been established that sin squared theta plus what? I have proved it to you there, so you've seen that. So, you know what I mean, that if we use this equation, we can derive other equations. We can derive other equations. Yes, it's very possible. So how do we do that? If we derive this, if you say sin squared theta equals to 1 minus cos squared theta, we can say sin theta equals to the square root of what? We can use this derivation to get, even without using that triangle, you can use this to find cos theta. You can use cos to find sin and reverse is the case. Abi? Yes. Even with this, you have from cos squared theta equals to what? 1 minus sin squared theta. Abi? Yes, sir. So that cos theta can also be what? The square root of 1 minus sin squared theta. Is that possible? And also, we still have other identity to use this sin squared theta to derive. Now, if you have this equation now, sin squared theta plus cos squared theta equals to 1. Now look up. Dividing through by sin squared theta, something will happen again. Sin squared theta plus what? Okay, let me start with sin. Divided by sin theta, sin squared theta. You said that sine over sine is 1, right? What is cos over sine? So that we cot. What over sine? You can also derive an identity on ourselves. Have you? You can also make with this one subject formula. But if you divide by cos theta also, dividing by cos theta this time around, sin over cos is what? Abi? Plus 1. This one was 1 over. Yes, it's cosec. So these are basic quantities that you need to know in trig. Last one. So that is some trig functions we need to apply. Inshallah. All right, let's now see how we can get some complementary angles. If we have a triangle, so complementary angles. Now for complementary angles we have if you have an angle like this, now sin theta equals to cos 90 minus theta. So cos theta equals to sine. Now this is the angle. Sine theta equals to cos into 90 minus theta. And cos theta equals to sine 90 minus theta. Now let's see how we can use this to solve questions so that we understand what is applicable. They say solve the equation. So the question comes this way. Solve the equation. Sin theta equals to cos 35. B sin alpha equals to now C part of that question says cos 2 theta then D part of the question is cos x equals to Are you calling me? Are you calling me? Now we want to solve this. So we all know that sin theta is what? Cos 90 minus theta, right? So therefore, from that point, we can replace solution. So, know that sin theta equals to what? Cos 90 minus theta. So cos so that's going to be what? Since sin theta equals to cos 90 minus theta. So you have to replace sin theta with sin 90 minus theta. We will give us what? Sin 90 minus that angle we are talking about. And the angle is 30. Are you getting me? Yeah. For the first A part was, sorry, the first one was cos 35. Cos 35. So, that is so that sin theta equals to cos 35. Then cos 90 minus theta will now be equals to cos 35. So cos will cancel out cos. So, so that from there, 90 plus 35. 90 plus 35. Let's turn to the other side. 90 minus 35 degree equals to theta. Abi? So theta will now be 90 minus 35 is what? 55. 55 degrees. So you can do other ones for me now. These ones are bonus. So do that one next thing. Look at that guy pattern here. Yellow. So I want you guys to do the one for me. You people are not interacting at all, and it's very bad. Eh? I want young baby them you. Me so fuck up there boys. So sin theta equals to cos 3 theta. But you know that sin theta equals to cos that. So I was able to solve that first question as sin theta equals to cos 35 degrees. So for B, sin alpha equals to cos alpha. You can still do the same thing by saying that sin alpha equals to cos 3 alpha. But you know that sine alpha equals to sine what? Equals to cos into 90 minus alpha. So then cos so cos 3 alpha will now be cos 90 minus alpha. So that when this cos consider this cos, you see that 3 alpha will now be equals to what? 90 minus alpha. And 3 alpha plus alpha will now be equals to 90. So that my 4 alpha will now be what? 90. And alpha will now be what? 90 over 4. So 90 over 4 will give me 22.5 degrees. So you can still try and do that number C and D for me right now. Okay. When you represent the family, you represent the class. It is well. So, you've been able to establish these points with respect to complementary angles. And we know the identity. So identity, complementary angle, I'm going to touch compound angle, half angles. I will disgrace the business. But you doesn't give me fives, that's a problem. They don't give me. I might know vibes. What was it? I don't know vibes. So I need vibes from you people. But you cannot cheat nature. People have not been on street. Like us, we suffer on street. We tell you that to get straight to the even inside, I'm going to get the put on. You'll be our so that again, I will get the get if I get a power as well. When the dumb about, I'm not sure. Eh? I'm going to that we don't know. All right, please. This is time for question. So that from there, we great time for you to go again, relax, and come back fresh. Go back on the agreement. What's up? I do. So. Do you have any question? Ask.
I have a question. This fundamental activity that says that sin square theta plus cos square theta equals to 1, and we just derived another one that says that 1 plus cos square theta equals to cos square theta, which means that you want to write this equation in terms of 1. You can say that 1 equals to cos square theta minus cos square theta. But I'm asking if we do it that way, does it mean that cos square theta or cos square theta minus cos square theta is the same thing as sin square theta plus cos square theta?
Yes, no.
It's the same thing.
Oh, madam, what's up? Madam, what's up? I make a manager. They don't want to do it before. Please another question. I'm back on board and I'm back at that. I'm back at that pressure. I'm making me back. No more believe. So please another question. Just feel free to ask questions because they say no, if there is no question, nobody is going out. See, we can have open.
I will ask you any questions now.
So I can't go. So, ladies and gentlemen, for the 2 minutes that's remaining, please ask questions. Just if even though some questions you need to know, or me, I will ask questions. If you don't ask questions, I will ask questions. My friend, I hope you are ready to answer questions. Guys, you don't finish as it is now.
What is this ticker?
What?
Ticker.
What is what?
What is this ticker for?
A ticker.
The sign here.
Okay. I will take a 1 minute of an hour. Now I'll get free. I better answer that question. Smart. Baba, I will should find out something from you. Maybe I'll get science. Someone asked something from you that you are from science department. I mean, what is that theta for?
Ask this. What are you looking for? Answer.
Penis.
Theta is a trig function. It's a sign. It's a symbol in Greek. It's just like alphabet, A, B, C, D. All right. So, how long am I need about? 5 minutes. Yeah? Is it not possible? Is there any way if you give them 30 minutes to sleep? 30 minutes. About you can borrow the person. So that men sleep, come back, so that we will join them. No time now, yes, no time, men come there, make a teach them. Men just leave us. All right, class, please, let's just go for a break. And I will pass from, we'll just go outside, I will tell you. Hope you are happy now, right? So my friend is smiling again. All right, please, we were talking about trigonometry and we talked about some special light. Close the door. So we discussed about some special angles, and I gave out a question that we're about to start. And in that question, we were able to solve the first part of it, that they gave that sin theta equals to cos 35. You see, we had theta to be equal to 55 degrees. And also I gave you the second question, which was sin theta equals to cos 3 theta, whereby we had theta to be equal to 90 over 4, which came out to 2.5. It was about to solve the C part, that is cos theta equals to sin 2 theta. So let's solve that one right now. If you see in that question, it says cos 2 theta equals to sin 2 theta. So cos 2 theta equals to sin 2 theta. It is true that cos theta equals to what? Sin 90 minus theta, right? So therefore, if you have cos 2 theta, it's going to be equal to sin 90 minus what? 2 theta. So it therefore means that sin 3 theta will now be equal to sin into 90 minus 2 theta, which giving us 3 theta to be equals to what? 90 minus 2 theta. And from there we can see that this will cross over, you have that 3 theta plus 2 theta equals to what? 90 degrees. So 3 plus 2 is what? That will be 5 theta equals to 90 degrees. And from there, our theta will now be equals to what? 90 over 5. So theta will now be 90 over 5. If you divide 90 over 5, that will give you what? 18 degrees. So I want you to do that D part for me. Solve that D for me. Let's see how you can do that. Just with the same principle, you can do that D for me. Eh? With the same principle, you can do that D for me. Recall that in that case, cos theta is what? Sin into theta plus 22. So, can you do that for me? Let's see. This my friend is smiling again. I can see that smile. Eh? And the D. You don't do the D. Can you do that? Have you gotten something special? Cos x equals to sine x plus 22. What do you do about that? You know that cos theta is sine theta minus 90. So, have you gotten something special with what I've done here? Otto, your face has come back to normal. That sleep helped me a lot. Eh? Now we have the frequency to flow. A lot is our strength. So what do we do? Can you do that bit for me? Yes. So what do you have? 34 degrees. Has anyone gotten that? Yeah. Yes. So you understand that, right? All right, let's talk about if you have a special angle. Let's talk about special angle in trigonometry. Because special angle is very imperative. Special angle. When we talk about special angle, we talk about angle 30, talk about angle 60, angle 45. Those are three special angles. We also have angle 90, 180. They have some special angles we need to study. Now let's see how we can know some special angles. Special angles. Then we talk about their ratios. Let's start with angle 45. Angle 45 degree. You know, if you have a right angle triangle, this side of the angle is 45 degrees. 45 degrees. And it's a unit side. From Pythagoras theorem, if I call this A, BC. I can use Pythagoras theorem to get this place. Calling my point A, AC squared equals to AB squared plus BC squared. So this is going to be equals to 1 squared plus 1 squared, which equals to 1 plus 1, which equals to 2. And my AC squared equals to that. So, for me to get this point out here, I have to square both sides. So finding the square root of both sides, the square roots of both sides, that will be AC squared equals to the square root of 2. This will cancel out so that my AC will not be the square root of, so this place will be the square root of 2. And now from that point, I can use this triangle to get my sine theta, tan theta, and cos theta. The angles So from this triangle, my sine 45 degrees. Remember that sine equals to opposite all over hypotenuse. And the opposite of this angle, whether this side or this side, is 1 all over root 2. And from rationalization, we have the 1 over root 2 equals to 1 over the root 2 times root 2 over root 2, which is what? Root 2 over 2. And cos 45 degrees, which is adjacent all over hypotenuse. Adjacent, this is the adjacent to this angle, and this is also adjacent to this angle. So adjacent 1 all over hypotenuse. Hypotenuse is the longest side, which is root 2. This is the same thing, which is the same thing as root 2 over 2. Now tan 45 degrees, tan is opposite all over what? Adjacent. And from that point, opposite of adjacent, the opposite of this angle is 1. The adjacent is 1. And that will be equals to 1. So you have been able to summarize in angle 45 degrees that sine 45 is the same as cos 45, which is root 2 over 2. Are you following me? Now let's see another special angle, which is angle 60. You see, from a equilateral triangle, you know that the sum of a triangle is 180 degrees. So in a equilateral triangle, the 3 sides and the 3 angles are equal. And so if we use a perpendicular bisector and we call the angle that has a side of 2 units, special angle 30 degrees and 60 degrees. So if you have a triangle that has equilateral triangle with unit 2, you know that the sum of angle of a triangle is 180 degrees. You know what I mean? That for an equilateral triangle, the 3 sides and the 3 angles are equal. And so a perpendicular bisector bisecting this angle will make this side to be 1 and this side to be 1. And so this angle bisecting itself will give me 30 degrees and 30 degrees. So for Pythagoras theorem, if I call this A, B, C, and I call this point D, I can use Pythagoras theorem to get the corresponding value of this place. Because from Pythagoras theorem we have that A base squared equals to B D squared plus A D squared. And we've been able to get this. We've gotten this, we are looking for this. So therefore my AD squared will now be AB squared minus BD squared. So my AB squared here is 2 squared minus BD, which is 1 squared. Are you following me?
Yes, sir.
So my AD squared will now be equals to 2 squared is what? 4 minus 1. So that my AD squared will now be 4 minus 1 is 3. And by virtue for you to take the square of both sides, taking the square of both sides, my AD will now become the square root of 3. So this place automatically becomes the square root of 3. And with that, we can use that place to get the special angle of 30 and 60 respectively. What do we do now? Let's take from Pythagoras' theorem, we've been able to get this, of which the angle will guide us to have angle 60, sine, tan, and cos of that. So bringing back the triangle we have, that the angle that was a 60 degree that was bisected by a perpendicular bisector give me this place as the root of 3. That is point A, D. And this is B, and this is C. So this was my angle 60 degrees, this was my angle 30 degrees, and this was 2, this was 1. The same thing happened to the left is happening to the right, and this is angle 60 degrees. I'm just giving a replica of that angle there. So if I want to find sine, let me start with sine 30 degrees. Sine 30 degrees. Remember what I told you about Socatoire. It's going to guide you. You know these things sometimes they go in school. For sine, is opposite of a hypotenuse, right? So sine 30, the opposite of 30 is 1. Abi? Then the hypotenuse is what? 2. Are we together? So this place is 1 over 2. Sine 30 is 1 over 2. Can you just press your calculator and say something? Just press. It's going to give you 0.5. Maybe something like that. 0.5. So that is sine 30. And if you are talking about tan, let me say cos 30 degrees. Cos is adjacent of a hypotenuse. Adjacent of a hypotenuse, right? And what's adjacent of this angle? This is a right angle. Adjacent of angle 30. This is the adjacent. Adjacent is the angle by the side. So what? Root 3 over hypotenuse means the longest side. Are you? So the longest side. Let me just arrange it well by saying sine theta is opposite all over hypotenuse, which was the opposite 1 all over hypotenuse 2, and cos theta is adjacent all over what? Hypotenuse. And the adjacent of that angle is what? Root 3 over 2. So sine 30 degree is 1 over 2, and cos 30 degrees is what? Root 3 over 2. Are you following me?
Yes, sir.
Now let's go to tan 30. Tan 30 is always proving to be stubborn sometimes. As the name implies, tan. It's not all that popular like sine or cos, just being special. So tan. So we are going to get this to be what? Root 3 all over 3. So we've been able to establish that fact that sine 30, cos 30, and tan 30 has special angles, which we'll be able to get right here. Now, with the same frequency, we also do it for 60 in sine, 60 in cos, and 60 in tan. Can we do that?
Yes, sir.
So, see how it goes. It's 24, 04, 20, 24. Now, let's talk about sine 60 degrees. Sine 60 degrees. Sine opposite of our hypotenuse. This is 60 degrees. Either this or this still flow. Huh? So sine opposite. Opposite is what? Hypotenuse. Have you seen that? Then cos 60 degrees adjacent of a hypotenuse. Adjacent of this angle is adjacent. Adjacent, you are sitting adjacent to the brain box. Adjacent, someone by your side. Opposite. Me, I'm opposite you. So adjacent, this is adjacent to 60. Hypotenuse, from the word hype. Hype, the highest. Someone that hype makes something higher. So hypo, not the one using washing clothes. So hype is what? The higher, the longest side is what? So that's called 60. And tan 60 degrees is tan is opposite. Tan is what? Opposite of an adjacent. Opposite of this angle. Root 3. Opposite of this angle. Adjacent. What? Now, thanks. We can therefore talk about, we've been able to get 45. We've gotten 45, right? So we can summarize those angles, calling them special angles of what? Special angle of 45, angle of 60, angle of what? 30. So those angles will be very useful when we want to calculate in the calculation of trigonometry. So we can summarize those angles. They are special angles. Please take note of that, write them down. We are using them. It's very important. So if you have on those special angles, let's solve this and see. It said calculate example 1. Calculate the value of x in the diagram above. 48 meters, 30 degrees, and x. Look at this angle. They say you should find that value of x there. From the idea of what we've done here, with this angle 30, with this angle 30, which of the special angle can we use here? Why? Because we have opposite and what? Hypotenuse. Is that right? So sin 30 can give us that x very well. Have you? So sin 30 is opposite all over what? Hypotenuse. So from there you can make x such a formula. Is that possible? So let's see how we can get that done. From the diagram we have solution. Let's follow up. Let's do it together. Sin 30 degrees sin 30 degrees equals to opposite x all over hypotenuse 48. Is that true? That, my friend. I love your smile now. I always smile in the class now. That smile has come back. So we can cross multiply now, Abi? Yes. So therefore what happened now? X will now be equals to what? 48 times sin 30 degrees. Whether you want to write sin 30 degrees before 48, there is no problem. Huh? So x will now be what? 48 times. What is sin 30? 1 over 2. You see the angles have really helped. Without going to calculate and find this, just know that sin 30 is half. From there you now cancel out. What is the answer? X equals to what? 24. Was it measured in what? Meters. So 24 meters. Is that clear? Is it difficult? Now let's see how we can have a special case of finding y in this equation. It says in the diagram below, in the diagram below, A, B, C equals to 30 degrees. And BA was a 10 cm. Find y. And there's the diagram. That's the diagram. You have angle 30 degrees here. You have 10 centimeters here. I call this y. This is A, B, C. Look at that angle there. So what do we do? What do we do there? In the diagram below, A, B, C is 30 degrees. There's this place. It tells you that this place is 30 degrees. And now this place is 10. And now they say find Y. No matter how they turn the angle to confuse you. Eh? You can even have your hand to turn it right back. You turn back, have you? So come back, let me feel you well. Because if you keep it well, you can see it. It's very simple. Is that true? Yes, so in that case, what do we do? We are looking for Y. So that angle Y with respect to 30 is what? No, this place, opposite, right? It's opposite. And what about this one? Eh? Adjacent. Is that adjacent? Eh? Is that adjacent? Which one is the hypotenuse? What happened to this thing you see here? Eh? This thing, this shows a right angle triangle now. Eh? Have you not seen it? So, have you seen that? So this is opposite. This is hypotenuse. Eh? Is that accepted by all? So from there, so sine 30 degrees will now be opposite all over hypotenuse 10. Have you seen that? Opposite of hypotenuse. Which will give us that Y will now be 10 sine 30 degrees. That will be 10 times. I've given to you something that can make you remember sine 30 degrees without wasting time. Abi? What do you say? All equals to 1 over 2. What's the answer? 5. So Y is 5 centimeters. It's not fun. Now let's think about some special quadrants. The special quadrants. If I give you something to try for me, I believe you can do that. Yes, sir. Yes, sir. I'll give you an angle. Now look at that diagram I've given to you. Huh? It's beautiful, right? So give me the value of x and y. Give me the value of x and y. Benny's. Give me the value of x and y. That is 60 degrees. Give me the value of x and y there. Is that? Then what about the x? Another objection. Don't forget that I've given you some basic guidelines that will lead you to help you to do that very well. What do you have, Benny? Benny, what do you have? What do you have? Now from that angle you see, if you say opposite of angle, opposite of angle is 3, right? So opposite over adjacent. You can use opposite over adjacent to get x. Eh? Is that right? Use opposite over hypotenuse to get y. Do we have the same answer? You have the same answer. The same answer. X and Y are not the same answer. Paul, have you done it? Huh? All right, let's see how it goes. Let's see how it goes. See, in most cases, the way they keep angles to confuse you You can return the angle and put it the way you want, the way it's supposed to look like. I mean, nobody will stop you for doing that. This is what I'm talking about. What if I keep this angle like this? I now give my right angle triangle. I do my 3 cm here. I do my y here. I do my x here. I mean, where was my 60? Eh? Eh? Is it not the same angle that was here? Is it? That's my friend at the back. Are you still with us? So, with this, we can make it easy. If you want to look for x, opposite of adjacent. Eh? What's opposite of adjacent? Tan equals the opposite. 3. This solution. Huh? Opposite of so therefore means that my x will now be 3 over tan 60. Is that right? That will be what? What is tan 60? Huh? What? Root 3. So this will now be equal to 3. Have you seen what I'm doing there? I rationalize. That will be what? Huh? This is 3. Huh? 3 root 3. Have you? Rationalize will be 3. Have you? Is that right? Yes. Is that correct? So we can also find the value of what? That one is what? Sine. Sine 60 equals the opposite. Huh? Sine 60 equals to what? Opposite over hypotenuse. So y will now be what? 30 over. What's sine 60? So the 3 divided by root 3 over 2. Divided by root 3 over 2. Abi? That will now be what? 3 times 2. Is that right? Huh? That will now be equal to what? 6 root 3. Which is what? 6 root 3. 6 over root 3 times what? That will be what? You're going to have 2 root 3. So, we've been able to get that as what? 2 root 3. Very special. Very special. Hope you understand that. So, trigonometry is always bonus. Now, let's talk about ratio of angles. Ratio of angles, we talk about quadrants. Ratio of angles, when we talk about quadrants. Yeah. I hope you have been hearing of, talk about first quadrant, second quadrant, third quadrant, third quadrant. That quadrant you see there are the trig ratios of angle, and they measured in anti-clockwise direction. You see, we divide the circle into 4 equal parts. When we divide the circle into 4 equal parts, one of those parts is called the quadrant. One of the parts is called the quadrant, and each quadrant has something spectacular. So let's see how we treat those quadrants one after the other. From the first quadrant, second quadrant, and the third quadrant. This is so ratio of angles. We're still on mathematics. Then we are on trigonometry. Then on trigonometry we discuss about, now we talk about ratio of angles. From 0 degree to 360 degrees. So we have the first quadrant. We have the second quadrant. We have the third quadrant. And we have the fourth quadrant. So the coordinate of points is what we use to know the ratio of angles in each of the quadrants for the 3 trigonometric ratios, where the angle lies between 0 to 360 degrees in each. So let me start with the ratio in the first quadrant. I'm starting with the first quadrant. You know, quadrant goes in anti-clockwise. See how this clock is moving? Clockwise. But quadrant goes in this other way. So this is the first quadrant. Second, third, and fourth. So as we are progressing in the quadrant we have. So for the first quadrant, we talk about ratio in the first quadrant. The ratio in the first quadrant So ratio in the first quadrant. This is what is happening in the first quadrant. We have if an angle sustains an angle theta, if I call the coordinate z, this is an x-axis and this is my y-axis. So the coordinate of points T, this point, are both positive. Because if you read from here to here and from here to here is positive. So we have the ratio, if you want to find sine, theta, cos theta and tan theta in this ratio. You see sine theta here, look up. Opposite. All over what? Sine opposite over what? Hypotenuse, when you said. It is still positive value. Have you? Let's talk about cos theta. Adjacent. Adjacent is what? All over what? Hypotenuse. Say positive. Have you? Tan theta. Opposite. Tan. All over what? Adjacent. Have you? Yes, sir. So that everything is still positive. So the ratio of angles are the first quadrant for the three trig ratios where the angles lie between 0 and 90 are all positive. So you can now summarize that in the first quadrant, sin theta is positive. Tan theta is what? Positive. Cos theta is what? Positive. You've seen that already. Now let's see the second quadrant. The second quadrant is going to be a different ball game in the second quadrant. For the second quadrant we have second quadrant we have now the quadrant falling here, that will be 180 minus theta. So we call this angle theta. So that point would be, it is going to be minus x over y. So from the above diagram, the x-axis are equal, but the value of adjacent. This angle adjacent over hypotenuse. That will be minus cos theta. Then tan is adjacent over hypotenuse. Opposite over adjacent. Opposite. Opposite over adjacent. It is minus. So that will be, so when the angle falls into the second quadrant, it shows that the sine of angle, because the sine is supplementary, so the cosine of the angle is minus. So the only thing that is positive here is the sine. Only the sine theta is positive. Every other trigonometry, the cos and the tan is what? Negative. I mean in that quadrant. In the second quadrant, only sign that is positive. Are you following me?
Yes, sir.
Only sign is what? The cos and the tan are negative. So, let's see an example of, so if you want to solve something in that first quadrant, second quadrant. If you want to solve like sine 35, sine 135, you know that sine theta is equal to sine 180 minus theta there. So, sine 135 sine 135 degrees cos 150 degrees and tan 142 degrees. Let's see what happened there in that quadrant. You know that since they said that which one is positive? Sine. So if you say sine 135, it's going to be sine 180 minus 45. Sine 180 minus 45. If we want to talk about cos 150, that will be cos 180 minus 30. So it's going to be what? Tan 40. So let's see. This will be sine what? Sine 180 minus 45. And note that from this rule, sine 180 minus theta equals to sine 30. Sine 180 minus theta equals to minus cos theta, and this equals to minus tan theta. So if you have sine 135, it's going to be what? It will be sine 180 minus 45, because the angle of sine theta is 180 minus theta. Are we? 180 minus theta. Look at in the first quadrant. Sine theta is what? 180 minus theta. Sir? Sin 135 equals to sin 180 minus theta. 180 minus theta. And the others. So that will be sin 180 minus theta. Theta is 135. Sin 180 minus theta equals to sin theta. Theta is 135. Theta is 135. So that's why it's sin 180 minus 135. Eh?
Yes, sir.
180 minus 135 will give you sin. You flow. Let's do it now, you see. Eh? So that is the second quadrant. Let's go to the third quadrant and see what will happen. For the third quadrant, third quadrant. For the third quadrant, if the angle sustains here, in the third quadrant, I call this Z. X is negative, Y is still negative. So that is that. Negative X, negative Y. So you want to do sin theta opposite. Go wire now. All over Z. Still negative. Sin is negative. If you want to talk about cos theta, adjacent, still negative. Tan, opposite, still negative. So you see that in the third quadrant, only tan that is what? In the third quadrant, only tan that is positive. In the third quadrant. Sine and cos are negative. Then coming to the fourth quadrant, only cos that is positive. So that's why if you want to summarize, your quadrants, the summary of the quadrant from the first to the last quadrant will tell you that in the first quadrant, sine, cos, and tan are positive. The second quadrant, only sine. The third quadrant, only tan. The fourth quadrant, only cos. We can summarize that. The summary of the quadrants from the first to the fourth quadrants. All sine, cos, and tan. Sine, cos, and tan. Sine, cos, and tan, sine, cos, and tan. So, observe what I'm saying, that in sine, everything is positive here. Now, coming to the second quadrant, it is only sine that is positive here. Others are negative. Now, coming to the third quadrant, it's only tan that is positive. Others are negative. Now for the fourth quadrant, only cos that is positive. The rest negative. Invariably, it means that we can redraw this by saying that for here is all. Abi? For here is sine. For here is tan. And for here is cos. You see what I'm doing there? Yes, sir. Have you seen what I'm saying? This is a summary of the quadrant. The summary of the quadrant. We like you don't there for form. The back get form. So you've been able to understand that fact. So those are the special things you need to know about quadrants, which is very necessary. Very, very necessary. So I've been able to summarize those quadrants very well for you. Benny, is it far from you? Oh, sorry. This place. That time that you went outside, did you sleep? Manaya? It's more than. So, it is something special for you to know the special angles very well. But if you know the special angles, you can treat, no matter how the question comes, you can always stand the test of time and solve. Now we've been discussing more about this particular theorem, and we all understand how to use it. There are some cases they give you the side, one side of a triangle, and you're asked to find the other side of a triangle. So without a particular theorem, you find it difficult to understand what you're doing. So now I want us to go into Pythagoras theorem as a topic so that we can solve a lot of questions that come in. Then we apply the sine rule, the cosine rule, before we go to angle of elevation and depression, so that we know much about trigonometry. We have been able to discuss special angles, and we know special angles. We've been able to discuss Pythagoras theorem too on a lighter note, but now let's enter into the in-depth analysis of trigonometry. Now, Pythagoras theorem. Pythagoras theorem. So in Pythagoras theorem, we know that the square of the smallest side of the triangle is equal to the sum of the longest side of the triangle. We know that. So the relationship between the hypotenuse side and the remaining two sides is what is called Pythagoras theorem. So let's see how we can use them in solving problems. Now, you have a right angle triangle. So this is the idea of Pythagoras. Huh? Now if you have a triangle ABC, so we now find if you want to find a Pythagoras, it's just like having an angle and putting it this way. So the equation a squared plus b is used to solve any side. So, if you are given two sides of the triangle, you can use Pythagoras theorem to get the other side of the triangle easily. Very easily. So, you are going to see what to do there. If you have, they give you a triangle that has a triangle inside. And now in the diagram below it says solve the value of SR. They want to know SR. They want to know SR. But they give you the part. So let's see what we talk about there. You want to draw this thing? Brainbox. The guy is angry that I'm cleaning this and I wanted to draw it. The AC give us energy. Eh? Brother? Make it lively. Eh? Speak. Right. Now I don't spend energy. Now I don't want to. Now my energy be preserved. I don't rush because I'm going back here. Eh? But me, doesn't have energy. She's one that join. Eh? So all right, now for the Pythagoras theorem, they give you a diagram like this. In the diagram below, solve for the value of SR. They give you PQ, PRS. Now look at this. They say you should find the value of SR. You know that from that point, you said that with these 2 points, you can get this place. Eh? Is that true? That my friend at the back, you are distracting. What's your problem? Are you with me? Stand. Stand so that. Can you see what I'm doing? Can you see what I'm doing? Can you see what I'm doing? And stand like that and see. Now, I have a triangle inside a triangle. Is that your seat? As I have a triangle inside a triangle, so how can I get this place? I have this is a triangle inside the triangle. So how can I get this place? You've seen it now. You've seen it now. There's a triangle inside another triangle. Then, okay, now when I get this place, how can I get this place? Huh? When I get this place, I will use this and this to get all of this. Then when I get there and I subtract from here, I get here. You were distracting. You were distracted. Focus on what I'm teaching you now. All right, now, say for me that. Let me first of all find this angle. Then, all right, from Pythagoras' theorem, they are looking for this place. Are you following me? Yes, sir. But I have to find here. Yes, sir. When I get here, I can now get this place completely. That is from here to here. Is that right? Yes, sir. So now let's. So, I have to get points. Line PQ squared equals to what? We can say from Pythagoras' theorem. Find Pythagoras, PR equals to RS plus what? PQ. Look at that. Is that true? Huh? PR squared. This is this place. The longest side, the hypotenuse side. The square of the other side is the square of the hypotenuse side. That's Pythagoras now. Huh? So PR is 13. So 13 squared equals to RS. Okay, R, that's Q. So RQ, now PQ, right? So that will be 5 squared plus PQ. That's what we are looking for, right? Huh? I call him there. Now, PQ squared will now be equals to 169 minus what? So that will now be equals to 169 minus 25 is what? 14. So therefore my PQ will now be the square root of 144. Does that give us what? The answer is what? 12. So this place is 12. Okay? So when I get this place as 12, now I can now get my SQ. Huh? So my SQ is what? My SQ, my line SQ squared, it was the PS squared, PS squared minus what? PQ squared. Is that true?
Yes, sir.
So this place will now be equals to, what's P cubed? PA squared. 15 squared minus, what's, what's the answer? 225 minus. That's my SQ. So therefore my SQ squared is, so that my SQ will now be what? Is that right? So all of this is 9. From here to here is 9. Huh? But our distance was here that we're looking for, and we know that this place is 5. I hope you can get this place now. Yes, sir. Benny, if from here to here is 9. Yeah. Tita will get for her. As I make a relationship with her. I gotta get my Andrea. So, if I get this place as 9, and this place is 5, what do I get here? Huh? Why do I get 4? Why is it 4? But I'm asking you. Or you just hear they say 4. So why do I say that? This is a question time. This is interactive time.
It's because 9 minus 5 is 4.
9 minus, okay, from that distance to here is 9. And we get that place to be 5. Huh? So 9 minus 5 equals to 4. All right, any question? Any question? Ask question, this time for question. I did with you. This is how the house is supposed to be cool. Eh? Man, I love my one lock speed lane. All right. Another question? Yes. Okay, and I mentioned the name of the mat. Do I remember something? I don't remember saying something like that. Can you remember who else said I can remember? So did I mention Martin then? Okay, group data, yes. Is that part of what we are doing now? You have any? All right, now let's take a look at the major stories. Now, our SQ was 9. Eh? So when we have 9, from here to here is 9. I mean, so the remnant, which is this place that's remaining, you have to subtract 5, because from here to here is 5. From here to here is 9. So now you now say that, so therefore, SR will now be line QS. That's SR will now be what? SR will be equal to SQ minus line SR equals to line SQ minus RQ. Are you following me? Yes, so my SQ was what? 9 minus 5. And that gave us 4. That's the stuff. So Pythagoras theorem will really help us to solve some complicated questions that we have challenges. Now we want to talk about the sine and the cosine rule. We are going to finish everything about trigonometry today, because tomorrow I will go into another topic, mathematical induction. But then from there, I will enter a logic. Those are the course outline. Then from logic, I enter calculus. It's a combination of differential and integration. Eh? I just equated yesterday now. We were sleeping. So how the sequence that yesterday you go?